all, I would like to take the opportunity to extend a hearted welcome to all the attendees of Scientific Conference on Climate Change in the Caspian Sea, held by Caspicom and Tehran Convention Interim Secretariat, TCIS. Also, allow me to thank the organizer of this important conference for having brought us together in this video platform to discuss one of the main current challenges worldwide, which is without doubt climate change. Climate change is a major crisis of our time, and its impact is happening even faster than expected. Climate change has taken unprecedented prominence today due to the sharp increase of global temperature in recent decade. Certainly, no corner of the globe is untouched by the destructive consequences of this phenomenon. Here, the Caspian Sea is no exception. Climate change has posed a major threat to the ecosystem and biodiversity of the Caspian Sea. The Caspian Sea littoral states have been affected by severe climate change effects, including sea level variation, intensified floods, severe droughts, reduction of biodiversity, and aggravation of the desertification. These have led to unavoidable socio-economic consequences in these states. Therefore, there is an inevitable need for holding scientific and technical discussion on different facets of this existing topic to come up with recommendation that will lead to the better protection of the Caspian Sea. In this connection, this conference intends to cover a wide spectrum of topics, including climate change in Caspian Sea, modeling and long-term prediction of sea level changes, climate change impacts on its ecosystem and biodiversity, and also adaptation to climate change in Caspian Sea region. I sincerely hope that this conference, along with the 25th session of Coordination Committee of Hydrometeorology of Caspian Sea, which was held on the 25th of October, will be an effectively positive step in tackling the high priority problem of the Caspian Sea arising from climate change. Moreover, I hope that this conference will serve as a strong platform to enhance our cooperation in technical and scientific fields. Thank you very much for your active participation in this session. And again, I welcome you to this conference and look forward to your participation. Thank you. Now, I would like to invite Mr. Moher Aliyev, coordinator of the Interim Secretariat of Tehran Convention, to present his welcome remarks. Mr. Aliyev, you have the floor.
Thank you, Dr. Tajbakhsh. Good morning.
Спасибо, доктор Tajbakhsh. Здравствуйте всем. Добрый день, приветствую участников конференции.
It is an extreme pleasure and honor to address this conference today with an opening remark on behalf of the Secretariat of the Framework Convention for the Protection of the Marine Environment of the Caspian Sea, which is called in short the Tehran Convention. I'm pleased because we have been discussing the idea of holding this conference for the Caspian Sea region for quite some time. And today we see the realization of our ideas and ambition. I'm honored because together with our co-organizing partner, Caspicom, we're helping to bring together the region's knowledge on the modern environmental challenges, which affect lives in our current generation. And what is more important, it will affect lives of the generations of our children and grandchildren. Today, the Caspian region is known mainly for its hydrocarbon resources and the important transport routes connecting the East and West. At the same time, the Caspian Sea is home to a unique cultural diversity of peoples inhabiting its shores, collection of endemic flora and fauna, which enriches our global wildlife heritage, and geoclimatic variety, which demands its due place in the global repository of scientific data and knowledge. We are convening in uneasy times today when COVID-19 continues to rage, to claim lives and challenge our social and economic well-being. Just like the virus finds the weakest spot in our body and attacks it the most, the pandemic has revealed the weakest spots in our economy, social setup, and outlook on the future. The economic crisis triggered by the pandemic results from many earlier decades of putting economic growth and exploitation of natural resources above the sustainability of those resources and the health of our ecosystems. As a result, the impacts of this planetary scale pandemic are severely conditioned by three planetary scale crises, that is climate change, loss of biodiversity, and pollution and waste. All three of these planetary crises are relevant for the Caspian Sea region. However, the focus of this conference is climate change. And this is not by chance. As you all know, in just a few days, the 26th session of the Conference of the Parties, COP26, to UNCCC, will start its work in Glasgow, the United Kingdom. It is our hope that this conference will, among others, be perceived as an input of the Caspian Sea region to the global debate on the effects of climate change and ways forward. And I'm sure we will hear many presentations and discussions during these 2 days about the devastating effects of climate change and the ways of its mitigation and adaptation in the Caspian Sea region. So it's not my place nor intention to dwell on the technical side of the matter. I would like, however, to speak about the opportunities I see in this conference. The knowledge that mankind has accumulated throughout its history allows us to believe in our collective capacity to come out of a crisis building a better life, stronger economy, more equal society, and a more resilient environment to overcome the challenges we are yet to confront. The Caspian Sea region is a vivid example of the wealth and care nature gives us to cope with our daily needs and build a better future for our children. The century-long industrial exploitation of the Caspian Sea is, of course, responsible to a large extent for the environmental degradation we face in the region today. At the same time, the human potential that developed in the region over this period, modern technologies and understanding of long-term benefits of investing in nature allow us to draw a bright picture for this region. A region actively promoting its blue economy, building its physical infrastructures on nature-based solutions, and developing a climate-resilient and sustainable society. What we expect from this conference is the synthesis of the existing scientific knowledge on the impact of climate change in the region, which would help us boost a true basin-wide cooperation on the Caspian Sea and mobilize resources to jointly combat the negative effects of climate change. The conference is the first in its kind in the Caspian region, as it aims to build a firm scientific foundation for the basin-wide five-lateral cooperation of the Caspian states on the climate change mitigation and adaptation. The Tehran Convention was the first and for a long time the only legally binding agreement among the 5 sovereign states of the Caspian region. It was concluded soon after the breakup of the Soviet Union at the time of many existing differences among the littoral states on the legal status of the Caspian and the ensuing access to its natural resources. The fact that the 5 neighboring states found political will to start building common governing frameworks from the environmental cooperation shows the vital role of the environment for the development and prosperity of the region. Today, when the legal status of the Caspian is regulated by a dedicated convention and the hydrocarbon industry has put the Caspian region on the modern geopolitical map of the world, more than ever, we need to become concerned and conscientious about investing into the preservation and enrichment of the natural ecosystem of the Caspian Sea to ensure a sustainable and prosperous future for the region. The Framework Convention and its protocols create mechanisms for engagement among the parties. The will demonstrated by all Caspian states to work together for a healthier and prosperous Caspian region is a driving engine towards achieving our common goals. The wealth of scientific knowledge and rich diversity of people and cultures around the Caspian Sea is the key to success. With these words, I would like to thank all the organizers of this conference, the hard work that has been already invested into preparing for this conference, and I wish us 2 very successful and productive days ahead of us. Thank you very much.
Thank you, Mr. Aliyev, for your remarks and addressing our audience. Now, I would like to invite Ms. Darana Alimbayeva, representative of Caspcom and Director General of CAS Hydromet. Ms. Darana Alimbayeva, floor is yours.
Добрый день, уважаемые дамы и господа. Спасибо за предоставленное слово.
Good afternoon, ladies and gentlemen. Thank you so much. It is a great honor for me to welcome the participants of the International Scientific Conference on Climate Change in the Caspian region on behalf of the Coordinating Committee. Climate change is one of the most pressing global problems of our time. Taking into account the geographical location of the Caspian Sea, its vast territory, and remoteness from the ocean, these changes may be more noticeable. Let me give you an example for the period from 1976 to 2020. The coefficient of the linear trend of the average annual air temperature for the globe was plus 0.18 grades, and for the Caspian region it was even higher. Consideration of climatic conditions and assessment of their changes are necessary to determine the potential consequences and take timely and adequate adaptations measures. That is why at the 24th session of Caspcom in 2019, it was decided to prepare and hold a regional scientific conference dedicated to this issue. As follows from the conference program, the participants will discuss not only climate change in the Caspian Sea region, but they will also discuss the problems associated with it. This is first of all the impact of climate change on the Caspian Sea level. The effects of level fluctuations are most pronounced in northeastern shallow part, which belongs to the territory of Kazakhstan. It is also necessary to discuss equally important issues of the impact of climate change on the ecosystem and biodiversity of the Caspian Sea. It's necessary to discuss the economic consequences of climate change and adaptation measures. We are confident that this conference, organized under the auspices of the Coordinating Committee for Hydrometeorology and the Interim Secretariat, will become a significant international event, and once again will emphasize that without attracting information from these services, many of the urgent tasks facing the world community cannot be addressed. The representative circle of the conference participants confirms once again the importance of the studies for the conservation of the unique ecosystem of the world's largest closed water body, the Caspian Sea. I am confident that the outcomes of the conference will be useful not only to the governments of the Caspian littoral states, but also to the world community to make informed decisions on the problems of climate change and adaptation for them in the Caspian region. I wish you all successful and constructive work, and thank you for your attention.
Okay, thank you very much, Ms. Danara Alimbayeva. Representative of the Caspcom and Director General of CAS Hydromet. Let me know at this time, Ms. Andrea Hinwood, UNEP Chief Scientific, would be our next speaker. Ms. Hinwood, you have the floor, and we are ready to hear her welcome remarks.
Thank you very much. And thank you for the invitation to provide this brief message from UNEP for this scientific conference on climate change in the Caspian Sea. It's a privilege to be amongst such an esteemed group of scientists for this important conference. My congratulations go to the organisers, the Coordinating Committee on Hydrometeorology and Pollution Monitoring of the Caspian Sea, CASPCOM, and the Tehran Convention Interim Secretariat, through the organising committee consisting of representatives of the two organisations of the 5 Caspian states. So we've already heard about the significance of this event in terms of the Caspian Sea region and the environmental issues faced. I'm actually going to address my remarks on science and the benefits of science-informed policy, something that UNEP has always and continues to promote and which we need to keep in sight as we shift our focus from understanding the problems to effective and evidence-based solutions. More than ever, we need to make sure that the science of the issues we're dealing with are communicated effectively, that we address the climate change challenges and mitigate and adapt to the effects in this sensitive and important region of the world. UNEP is actively engaged in promoting early adoption of net zero with accelerated action in the next 10 years. And I'm sure you've heard about our recent emissions gap report and the importance of actually addressing climate change now with all stakeholders taking early action and implementing their commitments. Indeed, we are asking all sectors and governments to listen to the science and not to delay important action to enable a transition to renewable futures and circular economy. So the result of this conference will strengthen the science base, which UNEP and its constituency, the Ministers of Environment, need to convince governments of the seriousness of the problems we all face. The research highlighted will help us to catalyse and support the action required to implement the Tehran Convention with its ancillary protocols, and of course to secure a sustainable and environmentally sound future for the population of the Caspian Sea region. So this conference is a first step towards institutionally established scientific collaboration in the Caspian Sea region, and I sincerely wish you well in this meeting, the exchange of science in the region, and of course to underpin any of our actions that we take to actually solve our current problems. So I wish you well, thank you very much, and I'll hand back to our chair. Thank you very much.
Many thanks, Ms. Hinwood, UNEP Chief Scientist, for your welcome statement. Now I would like to have the message from IPCC representative as our, the last but not the least of our opening session. Let me to draw your attention to IPCC video address.
Thank you for the invitation to the IPCC to address the participants of the scientific conference on climate change in the Caspian Sea region. As the chair of the UN body for assessing the science related to climate change, I welcome the initiative of the parties to the Tehran Convention and the Coordinating Committee on Hydrometeorology and Pollution Monitoring of the Caspian Sea to bring together the scientists of the 5 riparian countries of the Caspian Sea to exchange knowledge and create a better understanding of the evolving climatic conditions of the largest inland water body on Earth. The Caspian Sea, with its unique and isolated ecosystem, its abundant oil and gas resources, and its long history of water level fluctuations, deserves special attention in the science of assessing and addressing the impact of climate change. We know that as a consequence of global warming, the shallow parts of this closed water body risk to disappear, while coastal zones may lose their viability as engines of economic development and host and thesaurus of endemic biodiversity, understanding how climate change may affect the living conditions and future development potential of the region seems more urgent than ever in light of the projections made by the IPCC. This conference may well complement and enrich the work and understanding of the climate risks and consequences pertaining to this important area covered by the IPCC assessment. May I encourage you to not only review, but also build upon the impressive amount of scientific research brought to this conference. The IPCC will be happy to assess the science and recommendations presented to and emerging from this conference. May I further encourage the organizers to sustain the network of scientists created, facilitating also the IPCC to collaborate with and benefit from the science community of the Caspian Sea region. I wish you a very successful conference. Thank you. Thank you for the invitation to the IPCC to add.
Thank you to IPCC Chair for his welcome state. At this stage, I would like to invite Ms. Elena Ostrovoskaya, Caspian representative, to tell us more about the formation of the conference, its program, and its objective. Elena, you have the floor.
Наша конференция по изменениям регионального климата.
Our conference on climate change in the region is hosted under the auspices of Caspian, as well as under the auspices of the Tehran Convention. And it's not a coincidence. Could you please open my presentation?
Just give us a few seconds. Daniel is going to put it on the screen.
Хорошо, я продолжу.
Okay, I will then continue.
Наблюдаемые в настоящее время необычные природные явления, такие как
Those climate and weather events that we can see, such as weather heat, such as waves of heat and other weather conditions, do not only worry the population of the Caspian region, but it also is a thing of a scientific interest. The next one, please.
On
October 25, we have organized another session of the Caspian meeting. At these sessions, the representatives of different weather sessions and weather committees were concerned due to the climate change. The reason for that is the sea level drop of the Caspian Sea. That is why we decided to broaden our cooperation and collaboration in the field of scientific cooperation. The coordinating committee uses this format not for the first time. As you can see from this slide,
две научные конференции в 2010 и 2015 годах по достаточно близкой тематике. Так что наша конференция продолжает хорошую.
Our conference continues to meet once in a 5 year and discuss the important problems on the region.
Отличие нынешней конференции от
The difference of this conference
заключается в очень активном
is in its active participation of the organization by k.г.н Secretariat.
привнесло новые смыслы в наше
It brought new senses in our discussion of climate problems.
всего это касается вопросов влияния климатических
First of all, it is associated with climate changes
возможных
in the sea.
мер. Следующий, пожалуйста.
The next slide, please.
Следующий слайд. Кроме того, это сделало нашу конференцию по-настоящему международной.
Moreover, that is what makes our conference an international one.
но и международной.
We attract attention from the international scientific community.
Прежде всего, был сформирован международный
First of all, we decided to shape the international organizing committee for this conference.
представители КАСПКОМ, секретариата Тегеранской конвенции, а также ученые 5 прикаспийских государств. Оргкомитет возглавил доктор Хамид Ализаде Кетек-Лахиджани, заместитель директора по исследованиям и технологиям
So we have the Deputy of Research and Technology, Iranian National Institute of Oceanography and Atmospheric Science. The next slide, please.
Следующий слайд.
The next slide, please.
Основные цели нашей конференции представлены на этом
Please look at the picture here. You can see the objectives of the conference. One of the most important is drawing the attention of the people of the region to the problems of the region. Moreover, we are going to discuss the results of modern discussions on our conference, the results dedicated to climate changes, its results and consequences. We want to find the spots in these results and prepare the agenda for the next researchers. The next slide, please.
Here are the main topics for the conference. We have 4 main topics for this conference, and they are presented on this slide. They include climate of the Caspian Sea region and its changes in the 21st century, the Caspian Sea level change, analysis, modeling, and long-term projection, the effects of climate change on the ecosystem and biodiversity of the Caspian Sea, and the last one, which is also very important, it may be devoted, I think, to some applied research, that is adaptation to climate change in the Caspian Sea region. Moreover, we have selected some plenary statements to be made, and we have selected main speakers. For the first session and for the first topic, we will have Svetlana Dolgikh. She will moderate the session. She's head of climatic research department of KAS Hydromet. In the second section, we will have Mr. Bolgov Mikhail. He's Doctor of Technical Sciences, head of the Surface Water Modeling Laboratory of the Russian Academy of Sciences. In the third section, we will have Natalia Ogar. She will moderate the session. She's corresponding member of the National Academy of Sciences of the Republic of Kazakhstan. And in the fourth section, we will have Mr. Murat Atajanov, who will moderate this section. He's director of the Caspian Sea Institute from Turkmenistan. We, as the organizing, believe that these 4 topics are the most relevant problems in the region. That was proved by what researchers said to us. The researchers sent many abstracts and many papers to us. All these papers will be presented to the participants during these 2 days. Thank you. And in conclusion, I would like to speak about some organizing issues. As you can see from the program of the conference, during the plenary session, we will have 4 main topics on main conference topics. Then we will have work in sections. Today we will have work in 2 sections. They are done in simultaneous mode. Please pay your attention. You have all the links in your programs to join these conferences. Each of the speakers will moderate each of the corresponding sections. Up to 10 papers will be presented during the work of the section. Then we will have Q&A section. After the conference, we will draw up a book of abstracts. We will include all abstracts on this book, and then we will publish it. The abstracts will be published in 2 languages, in Russian and in English. I hope that this book will be published till the end of this year. And in conclusion, once again, I would like to wish you all a successful work. Thank you for your attention.
Okay, thank you, Elena, for your comprehensive remark and all attempts you and your colleague have already done for organizing this conference. As you have already informed, we have 4 keynote speakers who are going to address us at this stage. Their focus mainly would be on the key issue on the Caspian Sea region as mentioned by Elena. So I'm going to invite Ms. Svetlana Dolgikh, candidate of Geographical Science and Head of Climate Research Department of RSE CAS Hydromet. Her presentation title is Climate of Caspian Sea Region and its Changes in 21st Century. Ms. Dolgikh, you have the floor for 25 minutes. Thank you.
Спасибо, госпожа председатель, за предоставленное слово.
Thank you for giving me the floor. So now there will be a presentation and I will start. And now I want to welcome all the participants of the conference. The topic is very important for all Caspian countries. So I believe that there will be a lot of interesting and important articles at this conference. My speech is dedicated to the climate change researchers in Caspian Sea region. I cannot make a full research. There will be a lot of more detailed presentations. And then we'll discuss this topic in detail. The next slide, please. The main abstracts of my speech is global warming, and it is continued, and it even accelerating now. Caspian region is characterized by the increase in surface temperature and changes in precipitation. Even now we can see the changes of climate, and I will draw some examples to illustrate it. More detailed, you will hear about the results in the following conference. I will talk about climate projections, indicating the following global warming and warming in Caspian Sea region. The next slide, please. The main source of information for global warming, which unites the assessments of different organizations, is the organization which publish the information about global warming. You will see here some facts about World Meteorological Organizations from 2022 year. They said that 2020 was one of the hottest years in the history of observing the temperature. It is a phenomena of pre-industrial phenomena. Moreover, the last 5 years were the hottest in the history of reservation, as well as the last 10 years. On the left corner, you can see a table showing the changes of global temperature. Below, you can see the maps from NASA research, where you can see how the climate gets warmer. So it is a map of temperature of 1090 year and of 2020 year. Moreover, unfortunately, the concentration of greenhouses continue growing. People's activity is influence the concentration of greenhouse gases, and carbon dioxide is continuing growing. Even the epidemic didn't help to reduce these emissions. In 2019-2020 was a high heat of the sea. Oxidation and deoxidation of the ocean is also continuing. It affects the fishing and other people's activity. A lot of regions of the world, and Caspian Sea region, of course, suffer from dangerous phenomena. For example, the continuity of changing heat and cold periods, droughts, floods, forest fires and storms. In the last 10 years, we fixed a lot of migrations of people. More than 23.1 million people moved to another place within the national border. The next slide, please. Speaking about the climate of the region, I can say that the climate is sensitive to the changes. East and north part of Caspian Sea is located in a very dry climate with a little precipitation. The amount of precipitation is less than 1,000 millimeters. The biggest amount of precipitation is on the south and west of Caspian Sea region, more than 1,500 millimeters, as it was stated in the statement of Iran organization. The summer in Caspian region is very hot. It is hot in all regions of Caspian Sea. Because of the meridional location of Caspian Sea, we have very severe winters. The temperatures are about 10 degrees below zero or 0 degrees. In the summer, especially on the east, we can see a very high temperatures, more than 40 degrees above zero. The average annual winter speed is about 3.7 meters per second. But sometimes there can be the speed of wind of 35-40 degrees. Absheron Peninsula is the windiest territory, and there we can see the highest wave, more than 10 meters in a second. Climate of the region is quite difficult despite this summer temperatures and small amount of precipitation in the most part of the climate on the Caspian Sea region. That is why climate changes bring the negative effect. The next slide, please. Speaking about the changes in Caspian Sea regions, we should remember of consolidated annual report of on the state and changes of climate sea of the seas member states. The latest report was in 2020. Here you can see the maps of the speed of changes of average annual temperature and annual precipitation amount. We can see that the temperature in the region is increasing rapidly in all seasons of the year. Moreover, the precipitation amount is different in the regions of Caspian Sea. The precipitation amount differs, but it increases, but not significantly. On the south of the Caspian Sea, even now we can feel the decrease of precipitation amount. Unfortunately, it happens during the summer when the temperature is very high, the air temperature is very high, and there is a lack of precipitation. The next slide, please. The changes occurs not only in the temperature and precipitation, there are also changes in extreme phenomenon. For example, there are more hot and days with the temperature above 30 degrees Celsius, and sometimes even more than 35 and 40 degrees Celsius in the summer. Hot periods are longer now. So the temperatures and the continuity of this period is higher. And there are fewer days when the temperature is below zero. It affects the ice cover of Caspian Sea. You will hear about this later in details. Speaking about climate changes affecting human body, we should mention a very important characteristics of World Health Organization. The continuity of the nights when the temperature is more than 20 degrees above zero. During that nights, people's body cannot rest from the hot day. But we can mention a positive characteristic. This is vegetation period has increased. But this effect is positive only if in this region there will be a good amount of precipitation and people can reach the clean drinking water. The next slide, please. On this slide, you can see the data on climate change in Iran. This is the information on the third report of Iran. Here we can also see the same features of climate change, which also can be seen in other regions. The amount of hot and warm days has increased too. As well as the increasing in periods without precipitation. The intensiveness of precipitation has also changed. In the table on the left, you can see that amount of precipitation in winter in south, in summer the amount of precipitation has increased in some regions. The next slide, please. Now I would like to tell you some examples of climate change's results. The next slide, please. As I've already said, the Caspian Sea region is characterized by the combination of the decrease of precipitation and increase of the temperature. Of course, it leads to the droughts in many regions of the Caspian Sea region. Here you can see some maps showing the phenomena of precipitation from October 2020 to July 2021. The summer of 2021 is characterized by a drought on the west of Kazakhstan, including the Caspian region. It also was a long period without precipitation, more than 9 months. In spring and summer, the temperatures were very high, on the west of Kazakhstan. As a result, there was a drought. A lot of farm animals died, as well as the vegetation. The next slide, please. This is the table from the working group working on climate changes. This table shows that North Pole, north part of the Earth, faces the decrease in snow cover in spring. You can see unusual for the May amount of snow cover. The same picture we can see in Caspian Sea region, especially in the river basins flowing into Caspian Sea. The next slide, please. One more example is decreasing of Caspian sea level. You will hear about this later on the section of this conference. I just want to say about this as an example. We can see that the sea is shorter now. It is also the result of climate change, of the global climate and regional climate. The next slide, please. Now you will see some slides about climate projections. I take them from interactive atlas. The next slide, please.
Проекции климата.
These climate projections include 5 scenarios. And the following climate changes. But unfortunately, the increase in temperature will be in the 21st century. The temperature will increase on 2 degrees. But in the middle of this century, the increase will be even more, the temperature increase. So we can face the change of global climate. The precipitation in many parts of the region and of the world will change. There will be more droughts. Because of high concentration, sea and land will be more slowly get rid of emissions. The greenhouse emissions will be irreversible in the following thousands of years. The next slide, please.
Excuse me, and sorry for my interruption. Considering time limitation, please wrap up your presentation, Ms. Dolgikh. Thank you.
Здесь очень быстро. Здесь показано
I will
ожидаемые.
be short on this slide. There you can see the perspective changes in the temperature in the Caspian Sea region. The annual average temperature will be increasing more than 30 degrees. The high temperatures, the days with high temperatures will increase too. And we also will see the insignificant changes of the precipitation amount. The right picture, you can see the decrease in precipitation. The next slide, please. The next slide, please. One more slide. The next slide, please. I would like to end my presentation with the Intergovernmental Panel on Climate Change. The report of this organization draws our attention and makes us act. We need to monitor and study the climate of the Caspian Sea region. Thank you for your attention and sorry for the time limit.
Thank you very much, Ms. Dolgikh, for your very comprehensive presentation related to the climate of Caspian Sea region and its changes in the 21st century. Now, I would like to invite Mr. Mikhail Olgov, the Doctor of Technical Sciences, Chief Research of the Water Problems Institute, member of Russia National Committee for the UNESCO Intergovernmental Hydrological Program. Mr. Bolokov, the floor is open for you for 25 minutes. Thank you.
Большое спасибо, госпожа председатель, за предоставленную возможность.
Thank you so much, dear Chair, for the opportunity to speak here at the international conference. Next slide, please. I will be talking about the review of the problems that we have considered in Russia. The sea level fluctuates and we cannot predict how much it will fluctuate. I will make a short report and will state the most important problems and challenges that were solved or that needs to be addressed. On this slide, you can see a scheme. This is the Caspian Sea and the catchment area. The catchment area is more than 200 million square kilometers, which is much more than the area of the Caspian Sea. The area of the Caspian Sea is nearly 360 square kilometers if we have an ordinary level of water, let's say. That is what causes many problems, many scientific problems. So the main problem is that the water resources of the Caspian Sea are formed by the basin of the Volga region, far away from the Caspian Sea. The sea balance is made up due to many other things. On the one hand, we can take a look at these processes as an independent ones, but on the other hand, it is hard to make any projections for the Caspian Sea fluctuations. We need to understand all the processes that take place in the catchment area. Otherwise, we will not be very precise. The scheme that we use is a rather simple one. There are many runoffs for the Caspian Sea, this way with nearly 300 square kilometers. The water evaporates. It is partially evaporated through the Karabas Gulf. The next one, please. Next slide.
Next slide, please.
The Russian scientists were discussing the problems of the Caspian for many years. They started to discuss the problems in the previous century. The water level started to drop very fastly. That also caused many economical problems. In the 1990s, we started to observe an increase in the sea level of the Caspian Sea. On the picture, you can see the damages that we faced. They were, of course, vast. The next slide, please. The sea level problem, of course, attracts scientists always. We would like to understand the perspective and the projections. We would like to understand the history of the Caspian Sea. On this slide, you can see the results of the sea level reconstruction that we carried out during the last years. You can see that this research covers more than 10,000 years of history. We can say that the fluctuations of the Caspian sea level are huge. Next one, please. Let's talk about the main challenges and problems that we need to address when we make forecasts for the Caspian sea level. One of the main issues here is the human factor, how people affect the sea level of the Caspian Sea. On this picture, you can see the result of the restored sea level, given the water amount that was taken from the Caspian Sea. If we use the balance model and restore the sea level,
в современных условиях он был бы порядка на 1 метр выше. Это вот характеристика того, что могло бы быть, каков эффект человеческой
the sea will be 1 meter higher. You can see how humans affect the sea level and how our actions can affect the sea level. The main line is the observed line, and the second one is the restored line. That will be true in this case if all humans disappeared. Of course, we need to take into account the human activity. This is a very important task in this case. Next slide, please. What are the main factors of this Caspian sea level?
Сток, 82% стока дает река Волга, остальное распределяется между оставшимися реками. Для того, чтобы понять, насколько существенна роль речного стока, обычно...
In order to understand how much, what role river runoffs play, we need to take a look at the table. Could you please take a look at the table so it will become clear for you? Take a look at the lines. Here we can see that the river runoff is the main factor that causes sea level fluctuations. But of course, there are also evaporations. They also affect the sea level regime. Next slide, please. These ideas made it possible for prominent Russian scientists Kritsky and Melkel do this formula. Of course, the time is short and I will try to show you as much as I can. These scientists decided to introduce a water balance model. It can be written in a rather simple way. Take a look at this formula. In the first formula, we can see the changes that take place annually. If we simplify this model, we will have the second line of this formula. It is rather simple. Take a look at the last line and the last formula. It appeared in 1940s. This equation, the last equation on this slide, may be solved by various models. In 1940s, it was solved mathematically and analytically. The main tasks of the forecast was made using this formula. So all the projections were carried out on the basis of this formula. It allowed to solve our problem. Next slide, please. There is another important aspect related to evaporation. That is the structure of shallow water areas. Rather recently, it was said in the previous decades that the evaporations of the Caspian Sea depends on the depth of water in shallow water areas. If the depth is smaller, we have more evaporations because of the warming of the water. And if the depth is smaller, then we have less evaporations. Of course, we don't have enough time to speak about that in detail, but I will show you the results of the research carried out. That is true for the Caspian Sea. We decided to observe whether the shallow water area truly has an impact on the evaporation of the Caspian Sea, and we found out that yes, shallow water area truly affects the evaporation. As you can see, in the region below 28 meters, we have the highest shallow water area. It was shown that we truly have some effect from this formula presented on the previous slide. Next one, please. If we speak about the Kritsky and Menkel's theory and try to make the forecast for the Caspian Sea level, what we were actually doing in 1995, where we see a huge increase in the Caspian Sea level, we can make the following result. If the climatic conditions are standard, then the blue line with red dots on it gives the forecast for the drop of the sea level. Why? The reason for that is that the sea comes closer to the line in which it is about to lose water. But if we have climate change and face climate change conditions, and if we have the same climate as we had in 1975 to 1995, then the sea level is likely to increase. But unfortunately, that didn't happen. We have stationary climate right now, and the forecast is made according to this scheme presented on this slide. Next slide, please. But it's not as simple as that, of course, with the hydrological regime. The climate change took place in the past, they take place in the future, and will take place also in our current state. We need to identify whether these models that we use for the Caspian Sea are relevant and whether they can be used also in the future. We need to find out whether they suit our problems and whether they are enough to make forecasts for the future. On this slide, you can see the Caspian Sea water level forecast. And here you can see the regime of the mean inflow to the Caspian Sea. The river inflow can be seen here on the slide. One of the tasks of this forecast to predict the sea level is to identify the model of the changes of the mean inflow to the Caspian Sea. We need to identify how it works in the present time, and we need to find out how it will work in the future. Next slide, please. In the second column, you can see some figures. These are the figures about the length of the time series. It changes, and it changes drastically. Next slide, please. And if we use this theory for the Caspian sea water level forecast, if we make a stationary model more complicated, then we will receive more changes in the Caspian sea level. Take a look at the mean root square deviation. This one shows that in order to give some more precise figures, we need to use a more complicated inflow model, namely the Markov model of inflow. Next slide, please. On this slide, you can see interesting histograms of the Caspian sea level. To the left, you can see the histogram until 1979, and to the right, for the entire period of the observations. We often discuss the idea of making a more complicated model to forecast the Caspian sea level. For example, when evaporations depend on the sea level, and in this case, the sea may be in very stable states. We offered models for this one. These models describe the schemes that are presented on the left side. We were observing this Caspian sea level for more than 40 years, and the process that takes place right now shows that there is no clear interdependence on the seawater level and evaporation, so we cannot use it in our future models, which I think is an interesting thing, because evaporations cannot be measured. They cannot be measured precisely. We can use only some data, only our meteorological observations. Of course, now we can use this data for future analysis, but instrumental observations are not enough. There are only calculations, there are figures that we receive, and we make our forecast based on these figures. Next slide, please. There are also modern approaches. They allow to take into account more complicated models. These models are also simplified, and they are based on the differential equation of water balance of Caspian Sea. These are rather simple models with rather simple equations. They describe the sea level fluctuations. When we solve this equation, we can make a forecast for the future, but only in case when we know how this process will look like in the future. Next slide, please. As a complement, I would also like to show the results of Mr. Radkovich, Russian scientist. He worked there for decades and made forecasts for the sea level. He has quite interesting results. He used Markov equations in the form of bilinear decomposition on systems. I will not speak about that in detail, but Russian hydrologists paid a lot of attention to the observation of evaporations, and they also introduced some problems, some models that help to solve problems with forecasts. Next one, please. And now a little bit about the climate change. We hydrologists are worried by what happens to the river flow and river inflow and runoffs. The temperature grows, but the runoff is not changing. Well, it changes, but not drastically, just a little bit. The runoff is growing to the Arctic region, but the Volga runoff is not growing. Of course, there are some exceptions. Here you can see the changes of the runoff for the Volga region. It shows how much the winter runoff has changed as a result of global warming. That is what we observe here in the region. We have evidence of global warming. In order to make any other further forecasts, we do not have enough projections of precipitation. Contemporary climatic models give some pronounced predictions for the warming, but we hydrologists need precipitation because we need precipitation for our models. We make them based on precipitation. Unfortunately, even the best models do not fit us and do not suit our needs. The last slide, please. And just a little bit about the Caspian Sea water level forecast. How do we do this? We do it based on the previously mentioned equations. We use differential equations, we use different models, analytical models, and analytical solutions. The results, however, may be identical. We can pay attention to various aspects, to non-linear aspects of the runoffs, and various interdependencies. Of course, it has to do for analytical results based on various equations. It is the Caspian Sea water level forecast for the long-term period. As you can see, if we have enough tools and enough instruments, we can issue a forecast only in the form of an interval. The middle blue line shows it. We issued this forecast a long time ago, but it is hard to make forecasts for the next 30 to 50 years. The results may vary. But the results that we have for the current situation are presented on the slide. We need to take into account many factors such as runoffs, evaporations, and many others. If we take about 10 square meters from the water, of course, that will cause no problem. It is a very complicated process. We cannot make any forecast for this for the long-term period. I would like to thank you once again. It is a very short review that I have made. We do it when we make forecasts for the sea level forecast of the Caspian Sea. Thank you for your attention.
Thank you very much, Mr. Mikhail Bolgo, the Chief of Research of the Water Problem Institute and member of Russian National Committee for the UNESCO Intergovernmental Hydrological Problem. Now I would like to introduce you our next keynote speaker, Ms. Natalia Olgard, Doctor of Biological Science, corresponding member of the National Academy of Science of the Republic of Kazakhstan and Russia Academy of Natural Science, Director of Terra Preloda Limited. Ms. Natalia Olgar, the floor is open for you.
Good afternoon. I'm happy to participate in such conference. For many years, I worked with researchers of the Caspian Sea. My topic is the effects of climate change on the ecosystem and biodiversity of the Caspian Sea. It is a very important topic nowadays. We have already faced such problems as losing a Aral Sea in Kazakhstan some years ago. We partly used the sea, and now we try to recover this sea, but the water didn't flow into it. So the problem of Caspian Sea is also very important and sharp. So my topic is devoted to the biodiversity. Biodiversity is a big complex of different systems, ecosystems, water, air, water systems, coastal area. It gives us the full picture. In recent years, we are observing that Caspian Sea shallowing. Its level decreases. So that is why fleet cannot operate regularly in the equatory of the Caspian Sea, in the coastal area. On this slide, you can see the prospective changes of the sea depth. There is a 25% probability that average annual depth on the k.g.n will be less than 0.98 meters, and ice-breaking routes will be impossible. Even now, they're impossible in the coastal area. Seasonal and daily changes can also lead to the decreasing of sea level to 2 meters in this region. Here, the question about the biodiversity, it is also very important. With the decreasing of sea level, the flora also changes. Some plants there are new plants that start growing there, and some plants are dying. Some plants indicating the global warming because they didn't exist earlier, now they exist in this region. In the equatory of the Caspian Sea, in the Caspian Sea, we can see a lot of different plants, 78, 79 flowers. There is 31 different types of these flowers. We mostly study the seedweed. So there are different questions about the biodiversity. For example, on the east part there is a mushroom, Grilla speliosa, which grows on the common reed. It is a new plant here. Probably it came from Asia, but some scientists say that it is connected with the climate change. But it isn't proved. There are 2079 types of seaweeds in the North Caspian Sea region. We can see some of these forms. The flora of macrophytes is 161 types and 82 types of seedweeds. The biodiversity is very representative in such of water systems. While regressing, some seedweeds suffer from lack of water level. So the other types of seedweeds start growing. There are a lot of different traditional types that have been growing in Caspian Sea region for a long time. Sacred lotus, white water lily, and other plants are growing on the border of Russia and Kazakhstan in this area, because the environment there is more suitable for them. In Etraus region, we can see 7 types of vegetation. So these are types which start moving to the land. There were processes of lake shallowing. There also were such situations. In the last years, the process of monitoring isn't so good because people mostly pay attention to the oil fields. For the last 10 years, there were no such researchers in this area. Some specialists working on the Caspian Sea problem, they find new objects, new types of vegetation which moved to Caspian Sea region. And here the shallow masses, the shallow water between Volga and Ural rivers, we see a lot of water plants, a lot of vegetation block the river. So there is a huge layer on the bottom of the river. Speaking about the warming of climate, of course, it influences some parts of this region because some vegetables growing in this area start to decrease in their amount. For example, sacred lotus, white water lily, and other suffer from this effect. They were closer to the banks of the river, but now the water shallowing, so they cannot live there anymore, and the amount of these plants decrease. We can try to prognose how the climate will change in the future, and the amount of this vegetation will change also. Caspian Sea, some water routes also influence the vegetation, and they influence badly because these transport routes can cause to the decreasing in amount of vegetation. In the east and northeast part of this region, there is a common reed and other vegetation. So there are a lot of traditional types of vegetation here. And the amount of earlier there were much more plants, but now there are about 30 types. So the amount of vegetation decreased, and probably it is connected with some technical questions with ships and other people's actions in the Caspian part of Kazakhstan. Sometimes in spring, we see there kind of mosaic, the distribution of plants. Sometimes after the water is gone, we see sometimes these plants move to land, or the waves move them to the land, and they have a good environment for renewal. The salty level is higher on the east, and sometimes it's even higher than in the open water. It is about 14 and 6 promils. That is because of a lot of salty plants. In recent years, of course, there are more anthropogenic influence. Because of storms, a lot of plants are damaged or they are moved to another place. As I already said, because of people interaction, a lot of plants are destroyed. Sometimes these open spaces cannot be vegetated again. Sometimes these plants start growing on another place because these plants have a kind of strengthness and they can continue growing after some interaction. Big changes in the biodiversity of the region are caused by the changes of sea level. In the northern part of Caspian Sea, the sea level increased on 2 meters, so the ecological facilities changed. And these facilities were very important for the vegetation of the bottom of the sea. So this changes the life of plants and their functions. Sometimes some plants just fall out the flora of this region. Now, the main problem is the formation of vegetation on the bottom of the sea. The temperature of the water is increasing, so we can see bad facilities for vegetation on the bottom. It is also connected with ships sailing here and other activity. All in all, we can see a worse life period for this vegetation. But sometimes they can renew after this. There is a 25% probability that on the East k.г.н field, the ice-breaking routes will be impossible. If it happens, it will affect badly for people, but for vegetation, it will be good because it can grow without any problems. All in all, k.г.н field includes many parts characterized by similar distribution of plants. The east part of the k.г.н is richer in vegetation. There are 12 types in East k.г.н and 8 types of vegetation in West k.г.н. The distribution has a mosaic structure. in this region. More than 30% of the bottom is free of vegetation. This is a typical process of bottom vegetation formation. During the researches made in k.g.н and future works connected with operation of oil field, and new types of vegetation were moved there, some flowers, some water plants, Patamageton pictinatus, and other new types of vegetation. And some other. There are two new types of red seedweeds, 3 types of green seedweeds, in the first years of the dynamic of vegetation in East k.g.н, in 1994-1996, there were only
80% и составили некоторые
there are changes. Many plants, on the contrary, lost its place in the Caspian Sea region. There was a variety of different plants and other invasive species that were present in this region. Some of them are monodominant societies. They have a small representation of other plants, such as Polysiphonia and many others. At the same time, we can see an increase of green plants that were absent in this region, such as Tobonium, Isotium, and many others. They are the indicators of stratification. Many different factors may cause the growth of these green plants.
So the reason for this is high temperatures in summer. And the reason for their distribution is saline activity. So a lot of green seedweeds can be seen on the monitoring stations, and they also distribute to the whole territory of this region. The significant changes in the vegetation can be dedicated with saline activity. Sometimes there was some mechanical damage caused by saline activity. But this influence is short in time. And they can be seen in the parts where the water is gone. So on the shallow places or even on the land, Here the situation has changed significantly because all water plants are not in good condition. Sometimes they don't produce seeds. The area of these plants decreases. So there are less, the amount of these plants is less. It is connected with the silt of the bottom of the river. It is caused by transport routes, and it also connected with the warming. The global warming is also indicated by the complex of green seaweeds and separated groups of red seaweed, which grow in different parts of the year. So here we can see new types of the vegetation. But this reorganizing of the ecosystem and societies on the shallow area can be seen now. This territory is characterized by small biodiversity of plants. The other parts located far away from the banks, located on the depth. So these societies operate well, and there is no significant changes in these areas. So that means that we need to monitor and control these places very attentively. For several years, the researchers haven't been made. We just need to see these sports and try to see how the sailing activities affects the biodiversity of Caspian Sea. We need to see whether there are any changes for better or for worse side.
Okay, thank you very much, Madam Natalia Ogar, for your nice presentation related to the effects of climate change on ecosystem and biodiversity of the Caspian Sea. Let me to invite our last note speaker, Mr. Murad Atajanova. Sorry for my pronunciation. He is the director of the Institute of Caspian Sea, Turkmenistan, and present us under the topic of adaptation to climate change in the Caspian Sea region. Mr. Murad, floor is open for you.
Большое спасибо, госпожа председатель.
Thank you so much, Madam Chair. Could you please open my presentation? Dear participants of the conference, First of all, I would like to thank the organizing committee represented by Caspian. I would like to thank the interim secretariat representatives. Thank you for the organization of this scientific conference. Can you hear me, colleagues? Yes, we can
Yes,
hear
we
you.
can hear. You can continue.
Before I start, I would like to thank the previous speakers. Here is my introduction. Identification of our region may cause various interpretations. The thing is that the area of the Caspian Sea basin is much bigger than the area of the sea itself. And those climate processes that take place in Eurasia are primarily based by the Atlantic, by the Arctic regions. They are identified also by evaporations of the Caspian Sea. That is why when we speak about the Caspian Sea region, we need to understand the basin of the Caspian Sea itself. It includes Caspian littoral states, but also many other countries from the Caucasus. Next slide, please. Dear colleagues, here are the relevant global challenges. These are climate change, the COVID-19 pandemic. As we know, currently we have many uncertainties due to this problem. We have lack of scientific knowledge in these areas, and that is why it's hard for us to shape an approach to combat and address climate change and other global challenges. We need to find ways for adaptation. Next slide, please. The Caspian Sea has its peculiarities. First of all, it is an inland drainless water body. At the same time, many rivers, more than 100 rivers, flow into the Caspian Sea. The main volume is for Volga, which is more than 80%, Ural, Terek, and many other rivers of the region. The other important factor of the Caspian Sea is that 3 out of 5 Caspian countries are continental states. This can explain and say a lot. That also includes the scientific research papers in the Caspian littoral states. Some of the countries has an access to the world ocean, so that is why the oceanographic science in Russia and Iran are historically strong and well developed. The next important factor here that we should take into consideration is the special legal status of the Caspian Sea. There is a convention that was signed on the 12th of August in Oktau. It is a convention on the special legal status. 4 out of 5 states have already ratified the convention, and we do hope that it will soon come into force and it will be ratified by the 5th country. It stipulates many factors and describes many important issues, such as international scientific collaboration, that also depend on many other actions. The next peculiarity of the Caspian Sea is the fact that in different parts of the sea there are different climatic conditions. There is also a dependence on the river runoff and the amount of precipitation. The most of the runoff is for the Volga River. Previous speakers already said that we have sea level fluctuations that are vast, And that also affect many other factors. Since 1937, we started to carry out various research projects on the sea level fluctuations, and we found out that the fluctuations may reach 2.5 meters. There are different concepts on the reasons of these fluctuations, but we don't still have a single opinion on the reason and causes of these fluctuations. So we cannot identify what leads to the fluctuations. That is why we cannot make forecasts for the sea level fluctuations. We can also see a high seismic intensity and activity in the region. It also affects various processes in the sea. The Caspian Sea is the place, especially the Azerbaijani and Turkmenistani part of the Caspian Sea, that has many volcanoes, many underwater volcanoes as well. And everywhere in the Caspian Sea there are fluids and gryphons. They also have an impact on various processes of the Caspian Sea. Of course, these factors may be interdependent, and they can also be of man-made nature. The next slide, please. Here are the main threats and challenges for the Caspian Sea. These are climate change, anthropogenic impact, ecosystem degradation, biological threats such as invasive species and various diseases. All these factors may be interdependent. At the same time, climate change has a global character and global nature and may affect all of the above mentioned factors. Next slide, please. Let's talk about peculiarities of the legal status of the Caspian Sea. That is a very important issue. The largest part of the Equatoria and the water column is located in the coastal states. The coastal states use the large part of the Equatoria and water column. We can also speak about the use of water biological resources in the zone of 25 mile. It is regulated by various national laws, and that covers some mutual water biological
сохранить использование водно-биологических ресурсов и управление их совместными запасами. Следующий слайд. Следующий слайд, пожалуйста. Изменение климата вызывает...
The climate changes can cause different ecological problems. These problems are similar with the problems of world ocean. This is the increase in surface layer temperature, the changes of hydrochemical properties, the changes of ice regime on North Caspian, the difference in the circulation and water circulation of the sea, the changes in the feed chain and extremal weather events. The next slide, please. Speaking about the climate change adaptation, we should mention the Caspian Sea's health, which includes the health of the people living in the Caspian region, and also the health of the ecosystem and ecological security. The next slide, please. The next slide, please. Speaking about the health of people living in the Caspian Sea region, we should mention the health food, the good water of good quality, and protection from infection diseases.
В свою очередь увеличивает антропогенную нагрузку на...
Of course, we have also an increased anthropogenic impact on the sea itself. When I speak about the health of marine and coastal ecosystems, we need to pay special attention to the preservation of habitats. We also need to establish protected natural territories. Of course, there are some protected natural territories on the territories of coastal states, but nevertheless, we need to increase the number of such territories. It should be addressed within the protocol on the biodiversity of the Tehran Convention. We should also take into account the transporter cooperation that covers sturgeon species, seals, and many other species of the Caspian Sea. Another important component is the sustainable economy of the coastal states. Of course, the questions and the issues of navigation are very important. It also covers the use of bioresources, aquaculture, and recreational potential of the sea and coastal areas. Previous speakers have already said that the sea level changes have a negative impact on navigation. We are facing shallowing, and that's a problem. There are also other factors that play an important role for the sustainability of the economy. The next issue is the ecological security of the Caspian Sea. First of all, we speak about protection from pollution, following ecological norms and regulations when we make offshore projects and when we implement different coastal projects. An important factor here is invasive species here and their impact on the ecology of the Caspian Sea. And of course, climate change. I mean, the global climate change has an impact on all of the above mentioned statements. Next slide, please. Here are the main problems of the Caspian Sea. Irrational use of biological resources. We have many problems here, for example, how to identify the permissible catch for all countries of the Caspian Sea region. We have also illegal catch problems. Talking about the habitat and biological biodiversity, there is a strong dependence on climate change, on anthropogenic factors and sea level fluctuations. An important role play also invasive species. If we speak about the pollution, then of course the main impact is made by the land sources like rivers, wastewaters of settlements and cities, agriculture in the coastal zones, groundwaters, and the use of mineral resources of the bottom of the sea, various underwater volcanoes, fluids, etc. Another important factor that is to be addressed is the cooperation of coastal countries, as well as the use of existing regional mechanisms. Next slide, please. Let's talk about cooperation of coastal states in the sphere of environmental protection. Here is what we can do. First of all, we need to assess the marine ecosystems and their functioning. That is the basis for the rational use of these systems that we can use for further adaptation to climate change. Next, we need to establish a system of monitoring. We need to monitor the conditions of the marine ecosystems. In this regard, we need to identify criteria that can be related for the assessment of marine ecosystems. This in turn will help us to identify trends. It will help us make forecasts and projections. Currently, we have such problems. Each state has a number of members in these processes, different actors. There is some kind of a fragmentation of information, and the approaches are also different. Next slide, please. There are some conventions and agreements on the legal status of the Caspian Sea. It is done to protect the Caspian Sea. First of all, we need to talk about the Convention of the Legal Status of the Caspian Sea. It contains the main principles of cooperation in this sphere among Caspian states. It is a formal convention. We should speak about the Tehran Convention and 4 protocols for it. Protocol of Aktau, Moscow, Ashgabat, and EIA protocol. There is also another protocol that is being developed, that is protocol on monitoring and assessment and exchange of information. Next one, please. We also need to speak about the agreement in the field of security in the Caspian Sea region. Currently, we develop a protocol on cooperation to secure navigation in the Caspian Sea. It seems that it has no relation to the protection of the Caspian Sea, but in fact it does. It has a deep connection. This document plays also an important role, and that is an important document for the protection of the Caspian Sea environment. There are also other agreements, such as an agreement on cooperation in the field of hydrometeorology of the Caspian Sea. There is an agreement on preservation and rational use of water biological resources of the Caspian Sea. There is also an agreement on cooperation in the field of prevention and liquidation of emergency situations in the Caspian Sea. If there are any problems, then these agreements stipulate the fact that countries are willing to help each other in order to prevent and liquidate the problems. Currently, we develop another agreement between the governments of the Caspian states in the field of science and research projects on the Caspian Sea. Next slide, please. Dear colleagues, currently there are some mechanisms of cooperation for the regional states. They are of regional nature, of course. First of all, we need to speak about the Secretariat of the Tehran Convention. We need to talk about the Commission on Preservation and Rational Use of Water Biological Resources and their governance. We cannot but mention CASPCOM. It is very important. And we also have a high-level working group on the issues of the Caspian Sea. It works under the auspices of the foreign ministries. Next slide, please. Dear colleagues, when we speak about cooperation on the Caspian Sea, we need also to note that for the period of 2021-2030, we have a UN decade that is devoted to the ocean science for further sustainable development. Intergovernmental Oceanographic Commission was entrusted by the General Assembly of the United Nations to prepare a plan to hold actions within this decade. All 5 countries are partners of the Intergovernmental Oceanographic Commission, and we discuss our future plans for the next 10 years. Of course, we hoped to organize some scientific conferences this year. within the second Caspian Economic Forum, but unfortunately, due to the restrictions caused by the COVID-19 pandemic, we had to postpone this event for the next year, and we do hope that the next year we'll have an opportunity to hold this conference, as well as to discuss the participation of 5 Caspian states. We would like to cooperate in the field of the IOC Commission. Next slide, please. Turkmenistan is an active participant of the deliberations and negotiations process. During the 5th Caspian Summit in Aktau on August the 12th, we had a statement made by President of Turkmenistan, Gurbanguly Berdimuhamedov. He said that today the economic activities on the Caspian need strict economic support. It must be based on the science and on the understanding of what is taking place in the country and in the region. Next slide, please. We also have plans to organize a scientific conference and a seminar in Turkmenistan in the next year. The next slide, please. We also have another initiative. We need to make a new environmental program. President of Turkmenistan has noted in his speech that a special role is given to science in preservation of Caspian biodiversity. It means that all projects in the Caspian Sea must be made based on the high international ecological standards. In this regard, Turkmenistan supports the Caspian Ecologic Program as a complex of measures to preserve the biodiversity of the Caspian Sea region. This program could also monitor the ecological environment on the Caspian and shape new recommendations for the governments of the coastal states. Currently, we have developed a concept for the ecological program. We do hope that in the nearest future we will be able to discuss this problem in the bilateral and multilateral format in order to give an impetus for its further development. Annually, we also organized from 2013 to 2019.
Этот курс проводился совместно с Международным институтом океана. Это неправительственная организация, являющаяся партнером Организации Объединенных Наций.
Programs there. Here are some of these subjects presented in this module: the structure of the ocean governments, financial mechanisms for sustainable governance of water resources, mechanisms of management. We had 115 participants from all 5 Caspian states. I was pleased to see how the participants took part in this program. They have already graduated. This project was initiated by Turkmenistan. Next slide, please. Colleagues, earlier that was said that currently we develop an agreement on cooperation in the field of marine scientific research projects on the Caspian Sea. The main objective is cooperation of coastal states in the Caspian Sea region, as well as improvement of cooperation among universities, research projects, and the research institutions. This agreement will make some frameworks for the cooperation of the coastal states. It is, of course, very necessary because the largest part of the Caspian Sea is our common area. Next slide, please. We believe that we need the following things for adaptation to climate change. We need to develop scientific cooperation, first of all. As was said before in the previous presentations, there are some issues where we do not have common opinion or a single opinion. We have lack of scientific data, we have lack of research and lack of information. And of course, it is difficult to make any forecast and to take decisions. It's hard for politicians to make any decisions regarding the Caspian Sea region when we do not have enough data. We also need to improve the regional system of the environment assessment. We need to organize regional monitoring and share information. We need to teach people, train specialists, and also we need to raise awareness among all age groups. Information plays an important role, and each person that lives on the coast, each person that works in the sea or that travels by the sea also makes their impact on the man-made impact. If people pollute less, if they do not throw waste into the sea, that will be a huge positive factor for the ecological state of the Caspian Sea. Next slide, please. Dear colleagues, I took a look through all the agreements on the Caspian Sea. Currently, we have 16 agreements. Not all of them are ratified and into power. I took a look at how the climate change is reflected there. Of course, there is Tehran Convention. According to the convention, scientists touch upon the issues of the climate change, but it doesn't contain the word climate itself. But the word climate is part of other agreements, for example, a part of the Caspian agreement. In the preamble and in the very first part, when we raise concerns, we can see that there is a mentioning of this word climate. This text was prepared 10 years ago. The last speakers and the previous speakers also shared their view about the climate change, and they stated that it truly has an impact on the state of the Caspian Sea. Next slide, please. In the protocol on the assessment to the Tehran Convention, in the list of terms, we also speak about the consequences for the marine environment. It also includes the word climate. The next one, please. And in the very main document about the Caspian Sea, I mean the Convention on the Legal Status of the Caspian Sea, we also speak about the climate. That is probably the most important thing that we need to support. Next slide, please. Given the climate of cooperation, it is stated in the convention, climate of cooperation, of friendship, and of mutual understanding is very important for all of us. That's it. Thank you so much, dear colleagues.
Thank you very much, Mr. Murat, for your presentation. Again, I would like to extend my special thanks to all keynote speakers for the informative presentation, which are related and classified into 4 important aspects in Caspian Sea areas, including climate of Caspian Sea region and its changes in the 21st century. Also, the modeling, analysis, and long-term prediction problems for forecasting of Caspian sea level changes. On the other hand, the effect of climate change on biodiversity and also ecosystem of Caspian Sea was an important main aspects in this region. On the other hand, the adaptation with climate change as one of the solution for collaboration and coordination with each other, including the neighborhood countries around the Caspian Sea, is an important factor to environmental protection of this region. Now we are reaching to the coffee break, which will last 30 minutes. I would like to announce that our session starts again at 11 and let's up to 3:30 p.m. in Geneva time. It will be divided into 2 different rooms. In room 1, we have some presentation related to the climate of Caspian Sea region and its changes in the 21st century, which will be moderated by Ms. Dolgikh. In room 2, we have again some other presentations which are related to the Caspian Sea level changes with consideration of analysis, modeling, and long-term projection, which moderated by Mr. Dolgikh. The respective link I would like to focus on and draw your attention, participant attention. The respective link are mentioned to announce agenda. We are now in room 1. Participant who wants to go to room 2 will have to change the room 1 by leaving the meeting and connect room 2 by respective link in annotated agenda, which my colleagues in Geneva share with us on the screen. So now I would like to close the session, and I hope all of us have a active participant and look forward to you again in above mentioned plan and at 11 again, Geneva time in breakout session. Thank you very much and see you again soon.
Thank you very much.
Здравствуйте.
Здравствуйте.
Да, здравствуйте, коллеги.
Здравствуйте, здравствуйте. Это первым вы будете выступать, да?
Да,
Марал?
первый у нас госпожа Марал будет.
Мухаммадова, да? Из Туркмении.
Здравствуйте, да, в первой группе.
Здравствуйте. Здравствуйте. Ваш доклад был очень хороший.
Ну, не так, как хотелось бы. Ну, спасибо.
За что? Ну, проблема Каспия всегда очень интересная. Но, к сожалению, что сейчас очень страшные прогнозы дают. Не знаю, как поверить им или не поверить. Вот я имею в виду это немецких и голландских ученых, которые сказывают, что до конца века уровень Каспия где-то на 9-18 метров понизится. Можно поверить таким прогнозам?
Ну, вообще это, конечно, будет больше во второй секции рассматриваться, в параллельной уровень моря.
Да, да, да.
Ну, вот. Но вообще все равно за счет того, что сейчас уже все говорят, что очень много Каспий теряет из-за увеличения испарения.
Да, да.
А у нас именно запад Казахстана, там сильно вырастают температуры, поэтому испарение будет увеличиваться.
Да, да, да. Но здесь в настоящее время главный фактор – это температура, повышение температуры. Но, естественно, влияет на испарение. Да. Испарение – это главный элемент баланса Каспийского моря. Это баланс должен быть, это количеством осадков и этим речными стоками. Да. Вот так. А сейчас, по-моему, это очень страшно. Нас тоже спрашивают, что будет. Вот местные органы, да, вот это в Каспийском море, там планируют построить новые порты, да, свободная зона, экономическая зона этим, да. И нас просят, чтобы мы дали прогноз на 30-50 лет. Знаете, как трудно что-то сказать, да?
Очень
сказать,
трудно,
что
конечно.
там так сильно будет понижение, да. Ну, всякое может быть. Да, ну, через год, может быть, какой-то, не знаю, вулкан будет, там, извержение вулкана. 20 лет назад, да, картина может измениться, да. Было же. Но 1977 года все сказали, что будет дальнейшее понижение, вдруг начало повышаться.
Да.
Первого года. Да.
Ну, не знаю, что должно случиться.
Это уровень Каспия, это сложно, очень сложно.
Очень сложно. Но сложно еще потому, что меняется циркуляция,
да.
Глобальная циркуляция.
Да.
И, соответственно, как там, к чему приведет это изменение, ну, пока очень трудно сказать, потому что все-таки есть какие-то пороговые значения тепла в атмосфере, при котором еще можно как-то какие-то ориентиры давать. Если мы этот порог перешагнем, то там, ну, непонятно, что будет. Вот, например, такой яркий пример. Сначала, когда мы начали исследовать изменения климата, потепление было в зимний период. Сейчас весенний период. А зимой у нас сейчас на севере Казахстана, на юге Сибири, Западной Сибири есть область понижения давления в зимние месяцы. Ой, не давления, а температуры. Вот, то есть, как бы, такой очень интересная гримаса глобального потепления. То есть наши
я извиняюсь, вот для Азербайджана, вот я занимался климатологией тоже, да, самая большая аномалия в августе. в августе, самая большая аномалия. Вот за 30 лет, за последние 30 лет, самая большая аномалия это в августе. Но последние годы увеличивается аномалия и в марте, так, октябре там увеличивается. А ноябре, декабре вроде как будто, можно сказать, что стабильно. Можно сказать, стабильно.
У нас, как мы говорим, самый красный – это март. На всей территории.
Я извиняюсь.
Хорошо. Наталья, вы молодец.
Да какой молодец! Я тут с этой презентацией не стала даже ее показывать. Там 4 слайда всего мы не успели. Проблемы всякие были.
Не переживайте, у вас зато устно было очень много информации. Конечно, наверное, переводчики сильно напрягались в связи с названиями растений.
Ну, я так-то по-русски просто говорила, не латинские, не латинские названия, но у некоторых нет.
Но, тем не менее, устно-то вы все равно очень много информации дали. Ну и, во-первых, на слайдах показать какое-либо изменение.
Ну да,
это очень сложно.
Растительности, цветочки эти, которые там растут, на какой глубине, там то-то, и все. Так, конечно,
да.
Нет такой информации.
Ну, послушаем, что другие скажут на вашей секции завтра.
Потом прогнозы такие, все чисто тоже туда-сюда. Сейчас вон с оралом все опять поднялись тоже, начинают какие-то движения. Там от него уже почти ничего не Еще даже сейчас вода по Сырдарье доходит, не доходит туда.
Да. Угу. Вы выкладывали на разных форумах вообще абсолютно сухое русло. Но этот год был сильно такой проблематичный для восточного побережья, очень проблематичный.
Но вообще-то можно сказать, что вот экосистема уже не может поддержать свое существование в так как изменяющемся климате. Вот это пожары в Турции, в Южной Европе, что это показывает? Вот если дальше будет температура подняться и тепловые волны будут так устойчивые, да, тогда вот существование таких современных лесов уже будет невозможно. И это, по-моему, это будет конец света.
Да, но знаете, я сейчас смотрю на часы, уже 1 минута, да. Как мы должны начать официальную сессию.
Давайте.
Поэтому позвольте мне, но я смотрю, у нас около 50, более чем 50.
Dear colleagues, as far as I can see, we can start. We have about 50 participants in our conference. First, I would like to talk about the regulations of our conference. Unfortunately, we are short of time. We only have 10 to 12 minutes for your presentation and 3 minutes for questions and answers. We only have 1 hour till lunch. We will have 4 reports before lunch and then 6 reports after lunch. So we have different time in our countries. That is why in my country we will finish at 7:30. We will have various reports on modern climate, on various climate scenarios. And I think it will be interesting for everyone to listen to these reports. I hope that after the second part of our deliberations, we can have a discussion to discuss some points in detail. Now I'd like to give the floor to Ms. Maral Mohamedova. She has a report on the climate research in the Turkmen part of the Caspian Sea. You have the floor. Thank you so much. Hello. Please don't forget to mention the slides to be changed. First of all, I would like to welcome all of the participants of the conference. I wish you a happy day, and I do hope that our work will be fruitful today. My name is Maral Muhamedova. I work at the Climate Research Center in Turkmenistan. On the first slide, you can see our new facilities. That is our new building. Next slide, please. And the next one, please. The Caspian Sea is the world's largest undrained body of water. It has no connection with the world ocean, but its bed is formed by its Earth's crust of the oceanic type. So you saw the picture of our Caspian Sea, of course you all recognize it. Turkmenistan is a country in Central Asia. It borders on Kazakhstan to the north, to Uzbekistan, to Afghanistan as well. Turkmenistan is washed by the Caspian Sea from the west, i.e. it's one of the 5 countries washed by the Caspian Sea, the largest inland body of water on the planet. The state of the ecosystem and level fluctuations of the Caspian Sea, according to one of the most widespread hypotheses, depends on climate change. This hypothesis is based on the fact that after the Caspian Sea was once separated from the world ocean, it was completely at the mercy of regional and global atmospheric processes. They act not only within its catchment area, but also in other major areas adjacent to it. According to synoptic analysis, on the eastern coast of the Caspian Sea, a change in the atmospheric circulation system might be observed. Recurrence of such processes as western and northwestern intrusion has become more frequent, and also the trajectory of their movement has changed. If earlier these processes took place predominantly in autumn, winter, and spring periods, now they can be also observed in summer months. We can see strengthening of northwest winds, we can see formation of high waves with storm phenomena on the sea. The frequency of occurrence of South Caspian cyclones, not of the classical type, has also increased. Next slide, please.
Можно следующий слайд? Уровень замкнутых водоемов, таких как Каспийское
The
море,
level of enclosed bodies of water, such as the Caspian Sea, is determined by a delicate balance between precipitation and runoff on the one hand, as well as evaporation from the sea surface on the other. In the case of the Caspian Sea, they attribute the drop in water level to increased evaporation, loss of sea ice during the winter. Also, the impact of such climatic factors as wind swell, atmospheric pressure fluctuations, precipitation, and river runoff. There is only one river in Turkmenistan that flows into the Caspian Sea, that is the Atrik River. It is characterized by short-term floods from March to September. Often the maximum water levels and discharges reach critical values and are destructive in nature. The intra-annual distribution of flow within Turkmenistan does not reflect the actual regime of the river. As a result of water withdrawal on the territory of Iran, the flow is stopped during the summer period. There are 6 hydrometeorological stations on the Caspian coast of Turkmenistan. For example, Karabagaz, Tunglabagaz, Khazar, and other stations. They have been observing the sea since 1989. According to observations, the maximum water temperature of the past 10 to 12 years was increased along the entire coast by 1, 2, and in some years by 3 to 4 degrees. The highest water temperature may sometimes even reach 30 and 35 degrees. And if we speak about average temperatures, it is about 11 to 17 degrees. That is the average water temperature. The closer to the north, the higher the temperature. Sorry, on the contrary, the closer to the north, the lower the temperature. We also carry out observations of salinity on the Turkmen coast. We have 3 marine stations that are responsible for salinity observations. According to long-term observations, salinity values fluctuate within 12 to 14%. But in 2020, in Turkmenbashi Bay, there was an increase in July, August, and September, and it was nearly up to 16%. At Guvli-Mayak and Dugli-Bogas stations in summer months, salinity are always higher than in winter months. The next one, please. I would like to tell about the salinity and Dugli-Bogas stations. We have some long-term data and observations for this period. Sometimes we even reached the amount of 37 to 39%. All this data is evidenced. On this slide, you can see the annual salinity of the sea for the period from 2010 to 2020. The blue line is the Guldi-Mayak station, the red is Dugli-Bashi, and the green one is Dugli-Bogas station. The next slide, please. Could you please, the next? Separate observations of salinity can be said for the Dugli-Bogas station. Past studies show that due to the fact that winds are constantly blowing in the Gulf water area, the surface flow may be dramatically disrupted in some parts of it. Seawater flows into the bay through the strait at an average speed of about 0.6–0.7 meters per second. In annual seawater discharge, we can see decrease in winter time, and we can see an increase in June, July. It can be also observed. On the slide, you can also see the picture. This is our Dugli-Mayak station. We monitor the weather conditions automatically and manually. The next slide, please.
Марал, имейте в виду, у вас 2 минутки осталось.
Maral, you only have 2 minutes left. The next slide, please.
У нас южный Каспий замерзает, в основном только.
The South Caspian part freezes only in cold winters. The last time we had such situation was in 1969. During the past 10 to 15 years, we nearly have no ice. The width of ice may sometimes reach 500 meters. Starting from 2015, we do not see ice on the Turkmen part of the Caspian Sea. On this slide, you can see the following information.
Тенденция на повышение. У нас даже вот в прибрежных зонах, на отдельных районах, например, на станции Туркменбаши максимальная температура.
For example, at the Turkmenbashi station, the highest temperature was more than 40 degrees. The next slide, please. In this slide, we can see the precipitation amount, and here's another tendency: the precipitation decreases. This is the picture in Turkmenistan. In conclusion, I would like to say that Turkmenistan take part in solving the environmental problems We have a touristic zone, Avaza. It is a touristic zone which is developing, a green zone. It uses new technologies, uses alternative sources of energy. In recent years, the climate change and its results are the most important topics.
Nowadays, we have no doubt that the Earth climate is changing, and we need to address climate change. We need to do it together in the international community. Thank you for your attention. Thank you, Maral. Your presentation reaffirms the general picture for the region. I think that is true for the entire Caspian region. Often we have warming and also an increase in precipitation. Of course, that is a concerning problem. So you said that in the South Caspian region, there is a problem. What are the problems about trajectories? Are they more of the northern western or the eastern western? Sorry, we couldn't hear the question due to the connection problems. So here is my question. Can you hear me?
Сейчас выходят не по совсем обычной траектории. А вот чуть-чуть уточните, в чем необычность траектории. Не слышно? Извините, мы вас снова не слышим.
I'm sorry, I cannot hear you again.
Опять мы вас не слышим.
There are some connection problems, and you can text your question. You can type your question into the chat so that we can ask it and then answer the question. I'd like to give the floor now to Mr. Said Safarov. He will speak about modern changes in atmospheric precipitation on the Absheron Peninsula of Azerbaijan. Mr. Safarov, you have the floor.
Well, thank you for giving me the floor. Good afternoon, everyone. I'm happy to be in this important conference discussing such key questions. Please open my presentation. We're all talking about the global warming and climate changes. The next slide, please. As it known, in recent years, in Azerbaijan and in the most regions on the world, there was an increase in air temperature. The observations show that the temperature of the Caspian Sea has also increased. For the last 30 years, the temperature in Azerbaijan increased for about 6/10, 8/10 of degrees. But despite the fact that temperature everywhere increases, a lot of scientists say that the precipitation decreases on the contrary. In some places, the precipitation amount increases, and in the others, vice versa. So it is a very dangerous for environment. But my topic is modern changes in atmospheric precipitation on the Absheron Peninsula and on the stations Chilov and Nefteshlavy. The next slide, please.
Next slide. Следующий. Да.
According to the stations Sumgait, Baku, Mashtaga, Chilov, and marine stations, Chilov and Nevdashtari, the amount of precipitation has changed in 1961-2017. The next slide, please. This is the information about those stations. The information here shows the period and the amount of precipitation in these periods. As we can see, the precipitation isn't high, especially in marine stations. We can even say they are very low. The next slide, please. This slide shows the distribution of precipitation on the months. We also show the precipitation anomalies. The first number is amount of precipitation in millimeters, and the second slide is the percentage. As you can see from this table, on these stations in January, there are different. In Baku, the precipitation increases. Please open my slide. What we can say about this table? During cold months, we see the increase in precipitation amount. In warm months, vice versa. For marine stations, this table shows that the precipitation amount decreases. For some stations, for example, Baku, the increases in January and February, September, October, and so on. Statistical means import increase. The next slide, please. Statistic characteristics of the atmosphere precipitation for Baku station, and then for Chilov station. This is the information for 1961-1990. The first table accords to this period. And the other tables is for 1991-2017. So we can say that the statistic parameters has increased. For example, there was 65 as amount of precipitation and then 105. The next slide, please. For marine stations, we can see the opposite situation. Here we can see that decrease in precipitation amount. In cold period, we can see the increase in precipitation amount, and in warm period, we can see the decrease in them. For marine stations, the precipitation amount decreases during all year. The next slide, please. Here we can see the time course of annual precipitation for different stations. for the period 1961-2017. For the Baku station, we can see an important tendency of increasing. For Vashtaga, this trend isn't so significant, and for marine stations, there is a significant decrease. On the marine territories, we can see that precipitation amount decreases. So this tendency has changed. The next slide, please. Here we can see the information for above mentioned stations. The approximation characterize these changes worsen. These are not the linear changes. There is a kind of period character. The next slide, please. In this slide, we can see the annual precipitation amount of 5% and 1% for the above mentioned stations. If we look at the period of 1961-1990 and for the period 1991-2017, we can mention the significant changes. And the amount of precipitation has increased, as we can see. And for marine stations, we can observe the opposite situation. The next slide, please. With the average data, we can see that the tendency of annual precipitation on the stations also changes. This slide also shows these changes in Baku. For Baku stations, we can see the increase of precipitation amount, and for marine stations, we can see the decrease in the amount of precipitation. Up to 90s of the previous century, we can say that the precipitation amount hasn't decreased so significantly in that period on marine stations. But after this period, there was a very significant change for marine stations. If we take the period of 1990-1991, we can take it as a normal. So we can say that the changes are very significant. The next slide, please. This slide shows different seasons and the amount of precipitation for that period. In cold period, we can see the increase. The marine stations are an exception. In autumn, the decrease for marine station isn't so significant, but for the rest, there is a significant increase. In winter, the situation is the same. The precipitation amount increases. It proves that for the last 30 years, the cold period on Absheron Peninsula hasn't changed so significantly. There is a significant change for Baku station. For the rest station, the changes aren't so significant. The next slide, please. Said, you have only 1 minute left. The next slide, please. This slide shows the distribution of anomalies. The next slide, please. Here we can see the increase in the precipitation amount on the Absheron Peninsula, as well as the increase in the days with heavy precipitation. The red column shows the situation. The blue column shows the period of the last 30 years. The next slide, please. This slide shows the precipitation changes for the last 30 and 15 years on Baku station. For example, there were days with amount of precipitation 30 millimeters, but for the last 30 years, there has gone. There are no such days. But in autumn, we can observe the opposite situation. The next slide, please. I've almost finished. This is the Doppler radar image. The next slide, please. We won't stop here. So let's talk about the reasons for this situation. You can read them on this slide. This is the reason we think caused such changes in precipitation amount. So this is changes in atmosphere circulation, changes in evaporation, and changes on the territory level and anthropology changes because of building a lot of multi-story buildings. And of course, increase in concentration of condensation centers because of air pollution. Thank you for your attention. Thank you so much for your interesting presentation. I'd just like to mention some key points. I think we need to continue monitor the climate changes. We can see in your presentation the changes in precipitation amount in different territories. We also can see the tendency of increases in heavy precipitation, and in some regions we can see a very high amount of precipitation. For example, such situation was in Oktября. There was about 40 or 60 millimeters of precipitation for Oktябrya, which is a very high number. Thank you so much. Now I would like to give the floor for the next presenter, Galina Surkova, who will talk about storm surges in the northern part of the Caspian Sea and atmospheric circulation. There was a collective of authors. Galina, please.
Присутствовать на такой интересной конференции. Это действительно наша совместная работа с
Here present today. Well, it is a research that we carried out together with our colleagues. 3 authors worked on this project. We examined storm surges in the northern part of the Caspian Sea. Next slide, please. I won't go in detail.
Непостоянство уровня воды и очень большая динамика атмосферных процессов, несмотря на то, что Каспийское море удалено от основных траекторий циклонов. Но тем не менее, хочу подчеркнуть, что...
The Caspian Sea has no connection with the ocean, which formally allows it to be called a lake, but has all features of a sea. There are many factors influencing this area that form the wind direction,
ветры направленностью с юго-востока.
For more detailed study of this phenomenon, we took into account synoptic factor. In this regard, the purpose of scientific work is synoptic substantiation of the occurrence of such phenomena in the northern Caspian Sea. The next slide, please. We paid attention to the synoptic factor. It is movement of air masses and atmospheric fronts. The purpose of scientific work is synoptic substantiation in the northern Caspian Sea. These were our objectives. We worked with the formation of an electronic catalog. It is a calendar of recorded surges with the maximum values of sea level changes. Then we had
И проводилось, значит, по данным океанологическим стат-исследований показатели высоты, площади затопления и распределения нагонов в различных
seasons of the year. And then we had an analysis of synoptic situations. These are the factors that form a dangerous weather activity. The relevance of the study is associated with the active development and economic use of the resources. The next slide, please. There's just a small reminder. We talk about storm surges. Of course, under storm surge, we mean a flow of water moving towards the coastline under the influence of jointly acting wind, stress, under certain synoptic conditions. We also meant a change in water level in a coastal zone, or some water space with a period of several minutes to several days. And of course, under surge, we mean sea level disturbance. We were examining this phenomenon for a long period of time, but it still needs to be addressed and examined. We drew the main conclusions in the 1990s. We published some books on Russian seas. In these books, there was a large report and a large review on Russian lakes and on the reason of storm surges. We decided to go on to continue this work with the climatic conditions that we had during the last 20 years. The next slide, please. Here are the main factors of surge formation. These are wind, prevailing barrick system, atmospheric pressure, wind swell, interaction of the surge with the tide that can increase the intensiveness of surges, and of course, ice on the sea surface plays an important role as well. This is in addition to all the previous processes. Next slide, please. Here you can find about some atmospheric circulation. I will not go into detail. These are global maps, of course. The Caspian Sea here is a rather small lake. In the wintertime, we have a massive influence of various Asian cyclones. And in July, we have a small gradient barrick field. But this is a general picture. But nevertheless, against the winter situation that we have in January, we can see the Iranian branch of the wind flow. It also shapes very specific and very unique conditions that are only characteristic to this very region. It can lead to the acceleration of the wind speed. Next slide, please. What we used in our work was unique. We did it together with the chair of oceanography. We modelated various surges. We used the AdSurg model. We did it to assess the fluctuations of surges in the Caspian Sea. We used RFI free analysis as well. When using data on the stage of the atmosphere in the record cases of surge formation, we used RFI free analysis. This model modeled the surges in the northern part of the Caspian Sea. On our side, for each of the surges, we gathered various fields of atmospheric pressure and geopotential fields on the height of H500. That is about 5 kilometers. Next slide, please. In the bottom, you can see some detail. They were given using the modeling of the surges that was carried out using the AdSurg model. Of course, this problem also has its disadvantages that are related to calculations. But nevertheless, on the coast, you can see this net on the map to the right. It shows all details regarding the deepness of the coastal zones. Next slide, please. As a result, we worked with the surges that overcome the threshold values. On the maps, you can see different anomalies or deviations from the average annual evaluations. That is the data dated on March 15. The second picture is for the H500 deviation. You can see different deviations on the left map. For example, the red zone stands for deviations. That is the deviations for the period from 1981 to 2010. These are deviations from the annual recommended deviations. Of course, we have surges on the northern Caspian Sea. The wind moves perpendicular to the coast. That is why the water covers these coastal zones. On the right map, you can see that this case is true not only for the lower atmosphere, but also for the upper atmosphere. We can see high pressure fields here. They are green. And over the Scandinavia, we can see the blue zone, which formulates the wind surge. Next slide, please. Galina, you're nearly out of time. Next slide, please. And next slide, please. Next one. Here are some brief examples. Next one, please. We have investigated the rates of surges and we are ready to share this information. I can send this information to you because we have collected a lot of statistical data and statistical characteristics. Next slide, please. On the right map, you can see the territory that may fall victim to the fluctuations. Next slide, please. And the next one, please. We have identified two main surges and types of circulations. That is the continuation of what was done in the 20th century, and we are happy about this data, because the theories that we had earlier about surges came out to be true. They were reaffirmed, but we continue this research. We work in this direction, but we do it according to the modern slide. And the last slide, please. That's it. I think you can get acquainted with the conclusions we have made. You can read it on the slide. You can read our assessment and evaluation. So we have identified two main types for surface pressure anomalies. So you can read the presentation to get acquainted. Thank you for your presentation. Thank you, Galina. We are short of time, so please do not forget that you can ask your questions in the chat. Reporters, could you please kindly follow the chat, check it in order to clarify whether someone asked you a question or not. And could you please also answer the questions that people ask in the chat? We have one report left before lunch. This is a report on the simulation of dust emission in Gorgan Bay area in semi-arid conditions. The presenter is Ms. Parvin Gafaryan. You have the floor.
Yes. Hello, dear ladies and gentlemen. It's a great pleasure for me to attend this conference. My name is Parvin Gafaryan. I'm a meteorologist and faculty member of ILIAS. Sorry, my camera doesn't work. I'm going to talk about simulation of dust emission in Gorgon Bay area in semi-arid conditions. My colleagues in this research are Dr. Lahijani and Dr. Muhammadpur. My talk will be in 3 parts. In the first part, I will introduce the climate and climate change of Gorgon Bay. Secondly, data and methods will be explained. Finally, the results will be shown and discussed. Please, next slide. And next slide, sorry. Yes. Gorgon Bay is located in the southeast of the Caspian Sea in northern Iran. It covers an area of about 400 square kilometers with a maximum length of 70 kilometers and a maximum depth is 5 meters. Although a big part of this bay has a depth of less than 2 meters. The shallow depth of this bay has made it vulnerable to climate change. Please, next slide. Long-term, about 65 years trends of precipitation and maximum temperature anomalies for the Gorgon synoptic station to detect variation in these parameters were calculated. There is a decreasing trend in precipitation anomaly, and we can show 3.08 millimeter reduction per decade, which is considered significant. The anomaly of the maximum temperature showed an increasing trend and reached 0.02 degrees Celsius per decade, which is considered significant. Rising temperatures, high evaporation rates, and declining rainfall have increased the likelihood of Gorgon Bay drying up. One of the consequences can be a spread of dust in this region. To investigate this issue, simulation of dust emission has been done in the Gorgon Bay area in semi-arid conditions. Please, next slide. To conduct this research, we use observation and reanalysis data such as ERA5, satellite products, and atmospheric models, Warfchem model, and high-split model. Please, next slide. Warfchem is the weather research and forecasting model coupled with chemistry. The model simulates the emission, transport, mixing, and chemical transformation of trace gases and aerosols simultaneously with the meteorology. The model is used for investigation of regional scale air quality, field program analysis, and cloud scale interaction between clouds and chemistry. Please, next slide. This table contains the physical configuration for a simulation dust event such as surface layer and boundary layer, long and short wave radiation, and macrophysics. Please, next slide. In general, there are 33 options for selecting land vegetation in WRF model. This input data was changed so that the Gorgon Bay area was considered as a dry area with little vegetation. Soil material was considered as a proportion of sand and clay, which is about 80% sand and 20% clay, and the vegetation cover was selected as low grass. The model was run for 4 days and in different seasons of the year considered the weather conditions in the region during the year. The date selected in such a way that no precipitation had occurred in the study area for the past week, so that soil moisture was low and dust particles could rise from the ground. The first 12 hours of the run were considered as spinal. Please change the slide. In this study, also a hybrid single particle Lagrangian integrated trajectory high-split model has been used to generate an ensemble forward trajectory in order to trace the trajectory of the dust particle in the Gorgon Bay area. Now I would like to move on the next part and show the results. Please, next slide. This figure shows the pressure on March 5th, 2018, the existence of a low pressure system on the Caspian Sea and a high pressure system in central Iran has created a pressure gradient and instability on the southern coast. Please change the slide. In this slide, the simulation results of the model are shown, which was implemented for March 5th, 2018, and shows the concentration of dust in micrograms per gram of dry air. Heavy dust concentration is observed at the beginning of March 5th, 2018 in this area. Please change the slide. Please next slide. Yes. The wind speed and dust concentration trends at the Turkmen and gas port stations are shown here. The dust concentration reaches more than 1,000 microgram per kilogram dry air, and at this time the wind speed is 7 meters per second, which can be considerable. Next slide, please. Yes. The output of high-split model shows that on this time there is more convergence and less uncertainty in the risk, and there is a possibility of dust particles spreading to the northeast of Gorgon Bay. Now let me sum up my main points. Please next slide. In general, the results show that if the sea level of the Caspian Sea decreases, which results in the drying of the bay and its cover with grasslands, the Gorgon Bay can be considered as a source of dust. If the land is dry and there is no precipitation in the previous few days, with the wind blowing, sand and soil particles rise from the surface of the bay. Then, by the movement of atmospheric systems and the direction and speed of the wind, a significant area will be affected by dust. Also, the results show that the intensity of dust is strongly dependent on the wind speed in the Gorgon Bay area. So that if the wind speed in the study area is more than 7 meters per second, it is possible to create dust with a concentration of more than 1,000 microgram per kilogram dry air. Also, the most intense dust events at Gorgon Bay occur when the atmospheric pattern indicates low pressure and high pressure contrast in the study area and the middle levels of the atmosphere are stable. Finally, due to the weather conditions in the region, there is a possibility of transfer of dust particles from the Gorgon Bay to the west, northeast, and south of the region. The main point is Gorgon Bay can be considered as a source of dust. Many thanks for your attention.
Спасибо большое, госпожа Парвин.
Thank you so much for your presentation. Thank you for doing it in a timely manner. I would like to stress, as a result of your report, unfortunately, climate change and global warming and evaporation of water, as well as shallowing water, will of course have an impact on such atmospheric events like dust. And in Kazakhstan, on our coast, we also face this problem. The snow cover is unstable in Kazakhstan, and that is why already in February we may see some dust-related weather events. Unfortunately, that is a consequence of climate change. In the very end, I would like to thank all of the speakers. Thank you for your presentation that you gave before lunch, and I hope that after lunch, well, I know for sure that after lunch we will have some other interesting reports on various topics. So we'll see each other in an hour, precisely in an hour. It will be 13 or 1 p.m. Central European Time. Thank you, and see you in an hour.
Уважаемая госпожа Долгих.
Да, я вас слушаю.
А вопросы к докладам будем задавать в конце сессии. Я правильно понимаю?
Ну, у нас есть и в чате уже были вопросы и ответы. И я призвала всех пользоваться чатом, чтобы и докладчикам было на несколько минут больше времени. Ну да, конечно, у нас в конце будет время на 6 докладов, а времени побольше, чем до обеда.
Дело в том, что я веду, я являюсь репортером и веду запись.
The thing is, I'm a rapporteur, and I have to write down everything. That is why, of course, I would like all the questions to be said out loud. Okay, I will encourage people to answer questions and then follow the proceedings. I hope that we have enough time after the main session. My task is to write them down, and afterwards, during the session, during the plenary session, tomorrow we will have to tell about all these questions. That is why I need to write them down. We already have some questions in the chat, so that is why I hope that the organizers will copy these answers. I will take a look at them during the conference, but unfortunately during the session I cannot take a look at them. Thank you, Yelena. to the following issue. We would like to take a look at the Volga Delta hydrological regime under those conditions of modern climate changes. These changes are of various scales. Why do we think that is an important topic? Why do we speak about the Volga Delta? Through the top of the Volga River, we have more than 80% of freshwater runoff that comes and flows into the Caspian Sea. Of course, the hydrological regime of this huge water mass plays an important role, and it also defines the condition of the delta as well as the condition of the Caspian Sea. It also identifies the opportunities.
Без оценки гидрологического режима дельты очень трудно говорить, как нам кажется, о режиме Каспийского моря. В чем особенность? Почему мы обращаем на это внимание?
Okay, now that's it. The Volga Delta is a classic extension delta. It is formed on the open shallow northern coast of the Caspian Sea. Hydrological regime of the Volga Delta is influenced by natural, climatic, and anthropogenic factors of different spatial and temporal scales. The Volga Basin is one of the biggest ones in Europe, and it may fall victim to climate change. And the long-term runoff change that is shaped in the Volga Basin also defines by the
России. Но поскольку, собственно, дельта Волги имеет тоже громадную площадь, около 11 тысяч квадратных километров, то локальные климатические изменения, которые происходят,
anthropogenic factors play also an important role. They identify such important factors as thermic ice regime. The next slide, please. Let's take a look at what takes place in the delta. This issue was already discussed in the second room. If we take about the annual runoff from Volga River during the entire observation period, which is 140 years old, the annual flow didn't change drastically, so we cannot identify any clear trend. But of course, we see that within this 140 years, the annual runoff from Volga, we have changing periods of increased and decreased waterness. Currently, we have the decreased volume of water flow. Next slide, please. But these microclimatic changes that take place in the Volga Basin have shown a drastic impact on another important parameter, that is intra-annual distribution of inflow. Climate and anthropogenic factors work in one direction here, and this slide is there to prove my point of view. Take a look at the upper pictures. These are the calculations made based on the recently published books and based on our data that we obtained. We can see that, yes, of course, the winter runoff is natural. It is a natural runoff, and it has increased during the recent times. In the shallow water times, of course, it has decreased. But if we take a look at the runoff of the entire Volga Basin near Volgograd, then we can see that the increase of the winter runoff is much more evident than the decrease of the summer runoff. The reason for that is the man-made factor. On the upper picture, you can see the entire volume of water power stations that regulate the runoff as well. They have a huge impact on the intra-annual distribution, but together with the climatic change, we can see that in the winter and in the spring period, the role of regulation is added to the impact of climate change. In winter and in summer and autumn period, there are no drastic changes. Next slide, please. Now we go closer to the delta. How can we observe the changes that take place? We know what happens on the top of delta, but what happens in the delta itself? The observation network that we have for the delta of Volga is quite unique. Of course, I cannot compare this network with any other object because it is being observed rather attentively for a long period of time by many organizations. You can see that now in the Volga Delta there are 19 weather stations. One of them is in Kazakhstan and 18 of them are located in Russia. Moreover, we have marine weather stations. We measure volumes of water that come into the Caspian Sea. So that is the object that we pay very much attention to. We observe the situation, and we have been observing this situation for more than 70 years. Next slide, please. And now the next one, please. Next slide, please. Here are the volumes for average, maximum, and minimum annual levels in the Volga Delta. They are identified by the runoff that comes to the top of the delta. We can see that average annual levels have a trend towards decreasing. The runoff is decreasing as well. Take a look at the graphic. We have pointed out the level of 2021. That is the situation that we observed in September 2021. The slow waters that we can see currently is being rather extreme. During the period of the registered runoff, the minimum water levels that can be compared with the levels that we have now were only observed in 1975. But in this time, we had rather low amounts of water, and the experts can prove my opinion. We don't know how the situation will go, and we don't know what changes we can expect. But currently, the minimum water runoff for the lower Volga is due to the low level of water in the Volga Delta. Next slide, please. During the previous slides, we were talking about large-scale, macro-scale processes in the basin that identify various characteristics of regimes in the Volga Delta. But the thermic regime of the Volga Delta is identified by some local climatic processes that take place on this territory. We were talking about the peculiarities of the Russian part of the Caspian Sea, and we see that in Russia and in the Astrakhan region for 2020, the year 2020 was extraordinary. The average temperature, according to the local weather station, was 1 one of the highest temperatures that was nearly 12 grades. Next slide, please. That is a reaction of water temperature on the changes of air temperature. If we take a look at the warmest temperature, which is July, then we can see that the average water temperature and the average air temperature are simultaneous. The temperature of the water in delta is identified by the air temperature as well. But here we can see also spatial changes in the delta. The water temperature grows, and it grows from west to east. The warmest flows are located on the southeast of Volga. You can observe the highest temperature there. It depends on the air temperature on this territory. Next slide, please. Here is the most important factor, that is the thermal runoff during the flood period. It changes according to the changes that take place on the territory of the basin, according to the runoff volume, of course. Thermal runoff depends on the volume of the runoff that comes to the top of the Volga Delta.
Тепловой сток, и вот в настоящий период, в котором мы сейчас находимся, последние 15-20 лет, тепловой сток, поступающий в дельту, уменьшился по сравнению с естественным периодом практически вдвое. Конечно, это колоссальная разница.
There is a big change, and the ecosystem should be adapted for such changes. But of course, it affects significantly, and we should pay this fact in attention. The next slide, please.
И еще один важнейший экологически значимый параметр. Алло? Следующий параметр, на который мы хотим обратить ваше внимание, это ледовый режим дельты Волги. Пожалуйста, а можно отключить переводчика, чтобы он...
Да, у нас прорывается английский язык.
Да. Ничего, ничего. Но если можно, отключить. Так вот, ледовый...
So the ice regime of delta also depends on local changes of the thermal regime on the Caspian territory. We can see that the average annual temperature from November to March increased colossally. It increased from below 3 grades up to 0 grades. Here is an important factor. If the temperature would grow from But when the average temperature grows from below 3 grades to 0 grades, that means that there are years when the average annual temperature is positive, which means that the ice regime cannot develop.
Следующий слайд, пожалуйста.
И, Ольга, я хочу вас предупредить, у вас буквально 1,5 минутки.
Я заканчиваю. Так вот, говоря о ледовом режиме, я хочу обратить...
Olga, you are running out of time. When we say about ice regime, we can state that the data and the dates have shifted. The navigation shifted. Next slide, please. And generally, the length of ice regime has decreased by a month nearly. That means that the Volga ecosystem has to be changed for these conditions. And now, please, the conclusion. Next slide, please. In conclusion, I would like to say that in order to study long-term variability of thermal and ice regime in the Volga Delta, regional air temperature variability was considered as integral characteristic. And in addition, our institute also carries out some methodical work to classify and to moderate and observe the runoff. That is one of the most important parameters of the runoff change. We didn't observe it during the last 70 years, but now try to restore it and think it is one of the most important tasks. Next one, please. Thank you for your attention. Thank you for your presentation. If you have any questions, you are welcome to ask. If I can see your hand, you can just turn on your mic and ask the question. I would like to say that the river deltas are, as a rule, a high level of biodiversity if we compare it to other coastal areas. When the hydrological regime changes, for example, when the ice regime decreases, then of course it will result into the changes into the biodiversity. Do you have any questions, dear speakers? Thank you so much for your presentation. I would like to give the floor now to our next speaker. This is a report on the evidence of the so-called 4.2 climate event observed in the cores collected from the southern Caspian basin. Our reporter is Mr. Hadi Gerivani. You have the floor.
Hi everyone, good afternoon. Can I start? Excuse me, can I start?
Мы вас слышим.
Can I go ahead?
Yes, you can start. We hear you.
Okay.
Yes, please.
Good afternoon to everyone. First of all, I would like to thank conference organizer and scientific committee to give this chance to me to present my work here. The paper I'm going to present here itself is a part of a bigger project that was designed to assess marine polar earthquakes in the southern Caspian Sea, in the Iranian section, I mean. But during the analyzing the data, we understood that there is some evidence that probably can be linked to a paleoclimatic event that called 4.2 events. The next slide, please. The next one, please. Thank you. As you know, studying the past climate events can help us to understand the change that's happening on Earth's climate. This is in fact the famous word of geologists that say the past is the key of the future. On one of the interesting worldwide climatic change is called 4.2 event. This event happened in the mid-Holocene around 4,200 years before ago, I mean, and because of that called 4.2 event. According to the literature, it was a phase of intense erratic climate associated with cold weather. The figure I presented here shows the Earth's temperature during the Holocene. As can be seen, around 4,200 years ago, there is a fall in temperature that is related to the event we are discussing about. The next slide, please. The next, please. Thank you. This is a global map of areas where 4-point event has been studied by researchers. Red circles reported to be dry condition during the 4.2 event, and the blue squares showed wet climate during the event. As it can be seen, majority of the studies, especially in the lower latitudes, suggest dry and arid climate of time. The next one, please. During the ancient time, the 4.2 event was associated with cultural transformation in the human societies. There is an idea that this climatic event played an important role in the collapse of major ancient civilizations. Some of these changing civilizations are the following: the collapse of Old Kingdom in Egypt, the collapse of Akkadian Empire in Mesopotamia, that's including nowadays Iran, Iraq, and Syria, the collapse of Lingzhou culture in China, the collapse of the Indus Valley civilizations, and the migration of Indo-European speakers people into India. All this happens during this time, this climatic change event. The next slide, please. In spite of many evidences reported of this event within the low latitudes, rarely reports in literature can be found for the high latitudes, and there is no reported events in the Caspian Sea basin. The closest study to the Caspian basin, as can be seen on the map, is located on the Talas Mountains in the southwest of the sea. The green circle, in this study, the observations on the sediment cores collected in the southern Caspian basin were discussed that can be considered as evidences for the climatic change occurred around 4,000 years ago. The next slide, please. The map shows the study area, shows the eastern side of the southern Caspian basin where the studied cores were collected. 4 cores were collected in this area as shown on the map. Depths of water and the locations of the cores starts from 400 meters and ends in 700 meters. The next, please. The next slide, please. Cores were collected using a short gravity core. The length of studied cores are less than 2 meters. To test the sediments, first of all, magnetic susceptibility of the sediments was measured with 1 centimeter increment. Then cores were split into 2 sections using a handmade core splitter. Half of the cores were used to continuous XRF measurements and radiograph scanning. The next slide, please. The other half of the cores were subsampled every 2 centimeters for a total of 201 samples. Subsamples were treated to measure sedimentological parameters, including grain size distribution, calcium carbonate, and organic matter contents. And finally, bulk samples taken from different horizons of the cores were dated in Poznan radiocarbon laboratory by carbon-14 method. The next one, please. Results of tests and analyses are presented here briefly. As seen, almost all sediments fall within the range of silt to clay, sand, and coarse silt particles are detected just in some horizons. Based on the calibrated age, core BS400, the shallowest one, hardly cover middle Holocene, while BS600 could go back to younger Dryas and even older. According to the XRF sum analysis, the most considerable anomaly is the variation of the elements concentrations in the depths of 80 to 90 centimeter in core BS100, which will be discussed later. The next one, please. Please, another click. Please click one more. No, go ahead. Go ahead, please, 2 times. 2 click, please. Thank you. Anomalous sedimentary fascias and beds in the cores were identified and correlated to each other. This was done based on the variation of different sedimentological and geochemical parameters, and also considering the calibrated age determined by carbon-14 method. As seen on the figure, 7 anomalous beds were identified. We are going to focus on one of them that's shown by blue arrows and named B4 in figure. As I told in the beginning, this study is just a part of a bigger research, and other beds are out of the scope of this presentation. The next one, please. The next, please. The next slide, please. Thank you. The mentioned anomalous bed can be identified in all 3 cores, I mean BS400, BS500, and BS600. This numbers shows the depths of a core. It is characterized mainly by coarser sediments relatively to other cores, I mean. In spite of identification of this bed in all 3 cores, the evidence that show this bed probably can be related to the 4.2 climate events are observed just on BS400. I think the evidences are not clear in other 2 cores, mostly because the thickness of the anomalous bed decreased significantly in BS400, BS500, and BS600 cores. So here we discuss only on the observation and evidences of BS400. The samples were taken from the depths of 97 and 136 centimeter of these cores for dating. According that, non-calibrated age of the samples were determined approximately 4,950 before present and 5,110 years before present. The radiocarbon aids were calibrated to calendar years using the CalibRev software. And based on that, the anomalous beds of interest was deposited between 4,430 and 4,860 years ago. Based on geochemical analysis, the mentioned bed associated with significantly higher values of zirconium and titanium. The next slide, please. Here on figure, the log of the cores, the log of the core BS400 is presented. As can be seen, there is a significant anomaly on different parameters in the depths around 84 centimeter. That is the same discussing anomalous bed. During the amounts show the depths where the samples were selected for chronology. As discussed before, higher concentration of zirconium and titanium can be seen in the figure. The blue shadow, I mean. The high values of zirconium and titanium represent rather physical weathering and cold climatic condition. And as we discussed, the 4.2 event was associated with cold and arid climate. Therefore, it seems that the discussed bed may be linked to the climatic event of 4.2. The next slide, please. 3 short cores collected from southern Caspian basin were tested by different sedimentary and geochemical methods and analyzed to identify past events. For the first time in the Caspian basin, sedimentary and geochemical anomalies were observed on a bed aged between 4,430 to 4,860 years ago that can be considered as traces of the climatic event, so-called 4.2 event. These results show that the high latitudes also were affected by the event. Considering these 2 facts, that first, the climatic event like 4.2 have been associated with social and political revolutions that affected all around the world. Second, humankind is affecting with global climatic change nowadays. It can be claimed that the current change in climate will probably be followed by social and political change affecting even north latitudes. Thanks a lot for your attention. If there is any questions, I'm ready.
Спасибо большое за очень интересный доклад.
Thank you for a very interesting presentation.
You're welcome.
It again shows that climate affects the person, the development of the society, and this society have faced such crises many times, and people need to adapt for them. There are a lot of researchers on this topic regarding the global warming, which we see now, and this evidence show that there can be much more consequences. And now we have a question. Matthias, please.
Yeah, hello. Thank you, Hadi. I have a question. Are there any ideas what triggered this 4.2 kilo-year event? It's a global event, so what are there any ideas? What may have been the trigger?
Excuse me?
Are there any ideas what triggered this global climate event? Which physical mechanism, for instance? I know there was no grand solar minimum at this time, so it must be something else in the climate system which triggered this global event. Do you know if there are any ideas?
You know, this is a primary studies that was not our main purpose, but we faced with some evidence probably show can be linked to this event, and I think it is more studies, especially in the Caspian basin. I think I have no more ideas about this event.
Okay, thank you.
You're welcome.
Есть еще вопросы? Возможно, я не вижу чью-то руку. Вы можете включить свой микрофон и задать вопрос.
Do you have any more questions? You can turn your microphone and ask. As I see there are no more questions, so we are going to the next presenter. And thank you again.
Excuse me, can I say another point? This is just a suggestion.
Конечно.
Yes, of course, you can.
Yes. It will be very good if
Было бы очень хорошо,
in such international conferences,
если бы на такой международной
encourage
конференции
participants to present at least
организаторы
their presentation in
способствовали
English.
тому, чтобы
We
презентации
always have
говорили на
problem with their
английском.
presentations. All of them
Иногда у
are
нас
in
возникают
in
проблемы
Russian, and we cannot read at all.
с тем, что презентации написаны на русском, и мы не можем прочитать, что там написано.
Да, спасибо большое за этот комментарий. И, конечно же, этот комментарий надо учесть.
Thank you for such comment, and we'll take it into account for the future conferences, and we will make the presentations in 2 languages.
Thank you.
Вопрос у Елены. Вам слово, Елена.
We also have one more question from Yelena. Thank you. I've got such question. When you were talking about this event, as far as I understood, there was a change from warm and wet climate to dry and cold one. Currently, the world suffers from the opposite change. What do you think about the consequences about such changes? Will they be the same as in the past, as in the event you were mentioned, or they were different? Thank you.
Yes, you're welcome. If present my presentation file, the second slide, I will tell some interesting thing or some interesting idea, I think. The second slide of my presentation. Second or 3, I think. Second one.
Просьба вернуть презентацию и 2-й либо 3-й слайд.
Please open the presentation again, the 2nd or the 3rd slide. Daniel, please open the presentation again.
Presentation again. 2nd or 3rd slide.
This is the 3rd one. Please, 2nd one. Thank you. This graph shows, as you know, the temperature during the Holocene that start around 10,000 years ago. The Holocene starts with a warm an increase in temperature of Earth, and after that, the temperature decreases slowly down. If you look here, the Aries people migrated to the from northern latitudes to the southern. They maybe start around 8,000 years ago, and comes the countries nowadays, countries like Iran, Pakistan, India, their countries, and approximately around 2,000 years ago, it's got a bit warmer, and during these times, Arab peoples comes from northern latitudes. That was with war, I think. And I guess if again the Earth became warmer, then the peoples who live in the southern latitudes will start to migrate northern latitudes, maybe Russia, I think. And this is my idea that will happen if the Earth become warmer.
Спасибо, я поняла вашу мысль. Спасибо.
Thank you so much. I've understood your idea. Thank you.
Спасибо большое за ответ.
Thank you so much for your answer and for very interesting presentation. Let us invite the next speaker. The topic will be evaluation of climate model simulation on the Caspian Sea region. So we turn to the situations of climate in the future based on all the data we have. And the presenter is Ms. Kim Standelmeyer. You're welcome.
Yes, hello. Yeah, thank you for letting me present here at the conference. Actually, I won't go in the future, but rather also stay at present day or even at the paleo timescales, but we'll come to that later. Yeah, together with Patrick Ludwig and Joachim Pinto, I'm currently working on the evaluation of global and regional climate model simulations of the Caspian Sea region. And yeah, as you all know, the Caspian Sea is the world's largest inland water body, has a large extent in the north-south direction, and as it do so, it comprises several climate zones, from a continental and arid climate in the north to subtropical mild winters and warm and humid summers in the south. Now you can go to the next slide, please. Yeah, also the water levels of the Caspian Sea were varied by several meters in the recent past, or by almost 3 meters in the last 50 years. And next slide, please. And if we go further in the past, we see multiple regression and transgression phases with amplitudes of even more than 100 meters. And they are shown here in the figure just as exemplary phases. So yeah, such variations in sea level also lead to large variations in lake areas, can be seen here. And therefore also, of course, the area for possible evaporation grows and shrinks accordingly, which then has implications for the moisture availability in the atmosphere and for the regional climate. And we are working with climate model simulations to study the climate of the region. And therefore, next slide, please. The first question is, how well is the Caspian Sea region represented in global climate model simulations? And yeah, there are certainly many methods to study this question, but here I just want to show a qualitative comparison of selected global model simulations with the observations. And therefore, we choose some historical simulations of the current phase of the coupled model in her comparison phase 6. And you can stay here at this slide. So we use the last 30 simulated years of these historical simulations from 1985 to 2014. And we selected 3 global models to look at the simulation, that are the MPI Earth System Model, RVESM, and IPSA Climate Model. MPI and IPSA models are well established. They took part at almost all phases of the coupled models in her comparison project. And RV did this at the current phase for the first time, so it's kind of a new generation. And there exist different versions of the respective models with different resolutions. And we took those versions where also paleo simulations are available. And therefore we had to use the models at lower resolutions. And yeah, we compare this with error 5 analysis. And I just want to show 2 examples. So 2-meter air temperature, it's shown here, and then later on precipitation, both in long-term annual mean over the 30 selected years. And for the precipitation, for the 2-meter air temperature, we see a general agreement between model data and error 5 reanalysis data. The magnitude is comparable and the distribution from north to south as well. Now we can move on to the precipitation. So next slide, please. And first, we can take a look at the error 5 data. So most prominent is the orographic feature especially at the southern coast of the Caspian Sea, along the Elburz Mountains, and less pronounced, but also we have high amounts of precipitation over the Caucasus region and also over Zagros Mountains. And yeah, if we now look at the model distributions for the precipitation, it looks quite different. We have much less precipitations in the model than we would expect. At least over Caucasus region, we do have some precipitation in the models. It's a little bit more in the IPSL model, and there even, yeah, a small bit of precipitation over Zagros and Elburz mountain range. But yeah, overall, we can see that especially the local precipitation at the southern coast of the Caspian Sea is simply not existent in the models. And yeah, so to try and to find an explanation for this, we can first look at the Area 5 orography in the model. So on the next slide, we see the Area 5 orography. It's sure that it is complex terrain here, especially at the southern coast of the Caspian Sea. The height increases over very short distance, from 28 meters below sea level of the Caspian Sea to the highest mountain of the Elburz mountain range is at 5.5 kilometers in not even 100 kilometer distance. And this is in contrast to the model resolution. For the IPSL model, we have a resolution of 160 kilometers, and RV and MPI models even have a slightly lower resolution with 180 and 200 kilometers. So this has implications for the orography. On the next slide, it is shown for the other models, right? Yeah, so Zagros and Caucasus are visible, but not the Great Caucasus mountain range and not the Elburz mountains. Again, only for IPSL, we have a small idea of this. But neither of the models, the size of these mountain ranges are close to the original size. So yeah, the models do not know about the Elburz mountain, which generate the precipitation at the southern coast. And yeah, next slide, please. To overcome this gap, we suggest a regional additional to global climate modeling. And there we use global climate model data, or you can, you use global climate model data of the region for dynamical downscaling to achieve a higher model resolution. So so we can resolve more processes as for example, orographic features. And at the moment, we are developing a model setup for the region, again, using first Area 5 data, but then our focus will shift towards paleoclimate modeling. And yeah, we are not the first ones to try regional climate modeling, model simulation in this region. There are other studies, as for example, Adrindi et al. Or Kvic et al. From this year. But what is new is the regional climate modeling in the paleo context. And yeah, here we use, more specifically, we're interested in the regional climate of some selected time periods during the last glacial cycle, so up to 120,000 years before present. And the general idea of paleoclimate modeling is to test the climate models under completely different boundary conditions than today, also in a broader range than the last 100 years. Because in the future, we also know that the climate and boundary conditions will be very different than today, and we still need reliable simulations. And for the Caspian Sea, there are many open questions in the paleo realm, because the timing of the transgressions and regressions of the Caspian Sea is not completely correlated with the global development. And it seems that the Caspian Sea water level is rather out of phase with the global signal. And as an example, we can look at the last glacial maximum on the next slide, please. The last glacial maximum is the period defined as the most recent interval when global ice sheets were at their maximum size. It is approximately 20,000 years before present. And yeah, the global climate was colder and drier than today. For example, the surface air temperature were 4 to 6 degrees colder in global and annual mean. But even though it was drier globally, most probably this falls at the same time to the Qualinian high stand of the Caspian Sea, with a larger lake area that can be seen on the figure, and a regional climate that was more humid and not drier like the global changes. And yeah, this we want to study further with regional climate model simulations. Now I come to a brief summary on the next slide. So first, global climate models have difficulties in producing today's precipitation. We showed this for the southern coast of the Caspian Sea, and this is due to their low horizontal resolution. Then second, next slide, the regional climate modeling can improve the representation of the local orography And at last, rather as an outlook, regional paleoclimate modeling will lead to further understanding of the Caspian Sea water level variations and their influence on the regional climate. Yeah, with this, thank you very much. And I'm open for questions.
Спасибо, госпожа Ким, за очень интересный доклад.
Thank you so much, Ms. Stadelmeier, for your report and for your presentation. It proves that it's difficult and that it's rather hard to make any forecast for climate change. So we cannot hear the speaker. It seems that we have some connection troubles. Can you hear the interpreters?
Yes, I do hear you.
Okay,
Svetlana.
Yes, we can hear Svetlana as well.
Yes, we hear the interpreters, everyone else, but I think our moderator is gone for the time being.
Yes, probably.
Probably it would be able to give a floor to Mr. Prange to ask his question.
Yes.
Yeah, hello. Thank you for this interesting talk. So my question is, what is the spatial resolution of the global models that you mentioned?
Mm-hmm. So for the IPSL model, it's a little bit higher than the others. It's 160 kilometers, and for the others, 180 to 200 kilometers.
Okay, because in the last year in our paper, Nandini Weiss et al., so we compared in the supplement different model resolutions, 1 degree, 2 degree, and if you take 1 degree, 100 kilometers, then you get orographic rainfall in the Alps mountains, and also Caucasus is much better represented. So 2 degrees doesn't work at all. There's nothing, but 1 degree should work much better.
Yeah, that's also why we want to go to the regional scale, because at the paleo context, the global models only are available with these lower resolutions.
Yeah, okay. Yeah, thank you.
But yeah, it would be very nice, of course, to have this in a higher resolution also.
Yeah, just want to say 1 degree already makes a big difference compared to 160 or 200 kilometers.
Yeah, thank you.
Dear Elena, if you could act as a moderator for the time that Svetlana's computer is recharging. She has problems with the computer. If you can moderate this session for a bit, it will be very appreciated.
Коллеги, меня слышно?
Dear colleagues, can you hear me?
Да, очень хорошо, спасибо.
Yes, we do.
Слышно? К сожалению, наш модератор отключился.
Unfortunately, our moderator has disconnected. She will join us a little bit later. If there are no more questions, we can proceed to another speech.
Госпожа Штадельмайер, вы закончили ответы на вопросы?
Ms. Stadelmeier, do you have any other answers to the questions, or are you done?
Yes, I think I'm done. If there are no more questions, yeah, I'm ready.
Спасибо большое за ваше выступление.
Thank you so much for your presentation. Much appreciated. So my proposal is to give the floor to Ms. Azar Zarin. She will speak about projected changes in precipitation intensity in the southern coast of the Caspian Sea using a CMIP6 multimodal ensemble. You have the floor. You are welcome.
Hello, can you hear me?
Да, мы вас очень хорошо слышим, пожалуйста.
Yes, we hear you. It's clear. Thank you.
Okay, sorry, I didn't get you. So I assume that you are hearing me. Hello, everyone. Thank you all for taking time to listen to my talk today. I'm Azar Zarrin, Assistant Professor of Climatology, working in Geography Department in Ferdowsi University of Mashhad, Iran. And today I'd like to talk about projected changes in precipitation intensity in the southern coast of the Caspian Sea using a CMIP6 multi-model ensemble approach. Could you please bring the next slide, please? Okay. Okay, as we are all aware, precipitation is one of the key climate variables, and any changes in the characteristics of it in terms of intensity and frequency or duration is very important. One aspect of the changing climate is change in extreme precipitation of regional and global scale. According to IPCC, frequency of heavy precipitation events has increased. It is evaluated in many regions, and positive trend in precipitation extremes are also reported in many studies. Increasing the frequency of extreme precipitation events may have major impacts on society, causing floods, soil erosion, damage to urban infrastructures and water resources, as well as impacts on transportation and safety. Next slide, please. The purpose of this study is to project one of the extreme precipitation indices, STII, on the southern coast of the Caspian Sea. STII is simple daily intensity index and is defined as a ratio of annual or seasonal total rainfall to the number of days during the year or season when rainfall occurred. Next slide, please. So, okay, so this is the study area. The study area is the southern coast of the Caspian Sea in Iran. This region includes the three provinces of Golestan, Mazandaran, and Gilan. So you can see the topography is very complex here. The minimum height of this area is less than 26 meters, and the maximum is more than 5,600 meters in the Alborz mountain ranges. The Caspian Sea is the rainiest region of Iran also, and it is very important to study its precipitation changes in the context of climate change. In general, precipitation decreases from east to the west of this region, and also it decreases from the coastline in the south over the slopes of the Alborz mountains. You may notice the location of ground stations here. We have 7 synoptic stations of Anzali, Rasht, Ramsar, Noshahr, Babulsar, and Gorgan here. We use these stations to evaluate our CMIP6 models. Next slide, please. Okay, so we have two kinds of data. First, the 7 synoptic stations, and we have also 5 GCMs of CMIP6 here that you can see in the table. We have used precipitation of CMIP6 models from the Intersectoral Impact Model Intercomparison Project, ISI-MIP, archived for the first realization of 5 models of GFDL, IPSL, MPI, MRI, and UKESM. The resolution of all selected models is 0.5 degrees, and the models are bias corrected by W5E5 dataset. This is watch forcing applied to ERA 5. We evaluated each individual model by using some statistics, including root mean square, RMSE, MAE, MBE, and R2. But as we are short of time, I avoid to put the results here. Next slide, please. After evaluating the individual models, we decided to generate an ensemble model to reduce the uncertainty. So an IWM, the independent weighted mean method, is applied to generate the multi-model ensemble. Next slide, please. And here's the selected scenarios that we applied here for the projection. These are the new pathways that examine how global society, demographies, and economics might change over the next century. These SSPs are now being used as important inputs for the latest climate models that have been faded into the IPCC 6 assessment report also. Actually, these scenarios being used to explore how societal choices will affect greenhouse gas emissions, and therefore how the climate models, the climate goals could be met. The SSPs are based on 5 narratives describing broad socioeconomic trends that could shape future society. We selected 3 of them listed in this table. Yes, in this table, we can select 3. We selected 3 of them. A world of sustainability, focused growth, and equal, SSP1. A fragmented choice of resurgent nationalism, SSP3, and a world of rapid and unconstrained growth in economic output and energy use, SSP5. Next slide, please. Okay, we applied many non-parametric extreme precipitation indices, but here in this presentation, we just focus on simple daily intensity index, SDII. SDII is the mean of daily precipitation sum over 10 days, in which precipitation is greater than 1 millimeter. Next slide, please. Okay, and here are some of the basic results, some of the primary results. This figure shows the historical variability intensity of daily precipitation, SDII, based on CMIP6 multi-model ensemble. You can see that in general, the index varies from between 4.6 to 13.8 millimeter per day in the southern coast of the Caspian Sea, and its maximum reaches to 13.8 millimeter per day in the western Caspian Sea. In the southern part of the region, over the highlands of Alborz, the SDII is less than 10 millimeter per day. And in overall, the index is low in the southern Caspian Sea coast, despite the very high annual precipitation of this region. This indicates the homogeneous distribution of precipitation throughout the year. In other words, the SDII has not much contributed to the total annual precipitation in the southern Caspian coast. Okay, and the next slide, please. And this panel shows the projection of precipitation intensity, SDII, based on CMIP6 ensemble. We have 2 future periods of near future 2021 to 2016, the above panel, and far future in the bottom, 2061 to 2100. And also we have the scenarios in 3 columns. We can see from the figure that in most areas, except one point here, we have Ramsar here, except Ramsar in west of Azerbaijan province, there would be positive anomaly of SDII in other areas in future. The maximum increase in SDII is observed in worst case scenario, especially in the eastern part of the region. Comparing 2 rows representing the near and far future period, the SDII would be much bigger or higher in the far future. Accordingly, the contribution of extreme precipitation increases compared to annual precipitation. Overall, projections indicate that the STII in the eastern part of the region is higher than the western part. Due to the drier climate in the central and western coast of the Caspian Sea, southern Caspian Sea, this increase would be a serious threat to the surface water management. And my last slide, please. Thank you very much for your attention. And I would be happy if I can help with any question.
Спасибо большое, госпожа Азар, за очень...
Thank you so much, Ms. Azar, for your very interesting presentation. With your help, we observe the future for a little, and so the future changes of precipitation. And I've got a question. So you studied the 5 models. Can you tell us, please, how you choose these models? Have you tested them or not? Thank you.
Yes, sure. These are the ISI MIP models. As you know, we have many CMIP 6 models, and maybe more than 50 models are available here, are available now. But these models that I chose, these are the ISI MIP models, and they have only these 5 models in their website, and they downscale them for 0.5 degrees horizontal resolution. And I have no other choice. Only these 5 models are available for ISI MIP project.
Спасибо большое.
Thank you so much. Is there any questions for the presenter? If you have any question, please raise your hand or turn on your microphone. Thank you again. I don't see any questions. So let's turn to other presenter made by Alexander Gergerandi. The topic is Volga water flow under conditions of Holocene optimum and scenario anthropogenetic climate changes in the 21st century. Thank you.
Thank you, Mr. Chairman. Good day, dear colleagues. I'd like to present some results of our investigations concerning river runoff changes of Volga River caused by climate changes in some geological epochs and in scenario climate changes. As well, we analyzed and compared river runoff for 2 different contrast period of observational period in this river. This next slide. Здесь вот I will talk about in Russian. So мы рассматривали несколько геологических.
We took a look at some geological stages and eras during the Holocene optimum, which is characterized by a rather warm climate. The period that we considered was 3,000 and 9,000 years ago. We made our research based on this period of time. Moreover, we used the data from global scenarios for the climate change of the 21st century. We based our forecast on the well-known scenario estimations within 2 main programs, which are CMIP3 and PAMIP2. Our calculations were made in our institute, the Moscow State University. Next slide, please. Let's talk about paleoclimatic reconstructions. These reconstructions were based on the paleoclimatic reconstructions of deviations of air temperature and precipitation. They were obtained on the basis of zonal and informational statistical methods. We used two assessments for these changes. In one of them, the absolute value of the statistical error was added to the deviation of the climatic characteristic that was calculated from palynological data. In addition to that, we used the climate reconstructions for the Holocene optimum. It was obtained within the PMIP2 program. In this program, we used 18 global climate change models. The next slide, please. In addition to that, we use paleoclimatic reconstructions that we obtained using the global paleoclimatic reconstruction model. The research was carried out at the Moscow State University. Next slide, please.
Next slide.
We based our climate scenarios based on two programs, as I said before. Of course, we used not only all scenarios, but we only used two contrast scenarios with the lowest and the highest speed of the temperature change. Our estimations were made for two time periods, for the beginning and the middle of the century, namely. We used 10 models that were selected by us within the CMIP3 program. We did the research together with our colleagues. Regarding the results that were obtained within the CMIP5 model, we used all available models and added them onto the results list. We used average annual air temperature regimes. Next slide, please. In order to carry out calculations, we used the model of monthly water budget. You can see the equation for this model. The equation is true for the average long-term monthly water balance of river catchments. We paid attention to various factors and various processes. For example, the total surface and subsurface flow. Next slide, please. Here you can see the scheme of the processes that we used in our model. On the slide, you can see the main processes. Next slide, please. On this slide, you can see the results that we obtained. We have some characteristics on the thin line and on the thick line. The thick line shows the precipitation, and the thin line shows the river runoff for various time periods. The first one is the Holocene optimum according to the PMIP2 program. And number 2 and number 3 are the estimations that we received using the classical models. The fourth one is the modern level taken as 0 reference. And 5 to 8, we have scenario changes for the characteristics. You can see that for all those conditions, the temperature are higher than the modern temperature that we are having today. And in this regard, temperature consequently rises. And we don't have a direct interrelation between between rising of the air temperature and rising of evaporation and precipitation. The runoff for this situation seems to be lower than compared to the classical models. That is also true for other periods of times. Next slide, please. You can see the main trends for river runoff changes. You can see that the main changes take place in spring. Dark blue is the contemporary period, and light blue are the scenario changes for these two scenario groups. You can see that during the main runoff, the runoff constantly rises. So the runoff is becoming sharper, let's say. Next one, please. Here you can see how runoff changes during different periods of times for various seasons and annually as well. You can also see deviations from the current values of the average long-term annual . And on the slide we can see summer-autumn runoffs in the warm eras of the Holocene optimum and scenario future. The situations are different for spring and for autumn. The runoff is much higher in autumn periods. Next slide, please. On this slide, you can see intra-annual distribution of the values of deviations of the average monthly river flow from its modern values. You can see deviations on the scale of change may be different. Next slide, please. Now some words about contemporary changes. You can see the Volga runoff change on this slide. Green stands for various integrational curves. Below you can see the deviations for runoffs. Blue means positive deviations and red means negative deviations. That means that runoff drops and decreases. Of course, during the year, there may be increased and decreased periods for the runoff. As you can see, we have different situations for the runoff. What is important here is to say that all these changes are related to climate change. And the black lines show the boundaries of the long-term phases of the increased or decreased water flow.
Next, please.
Next slide, please. Here you can see comparisons of the runoff of two periods. A colder one from the 1930s to 1980, and during the last period from 1981 to 2014, of the period.
Здесь в абсолютных километрах кубических, а в знаменателе в процентах с предыдущим периодом. Годовой сток.
During the period of modern global warming, the naturalized annual runoff of the Volga increased by 8% compared to the preceding period. And the runoff changes drastically as well. Those estimations are given for the estimated flow. Of course, we cannot assess the man-made or human-made factor here. This nature of deviations between cold and warm climate during the observation period is rather simple to what happened in the past and to what we will have and expect in the future. Next slide, please.
Заключение, собственно говоря, здесь, наверное, нет необходимости читать. Спасибо за внимание.
So here are the conclusions. You can see them on the slide, and thank you for your attention very much. Dear listeners, do you have any questions? We still have time for your questions. You're welcome. I can see any hands raised. I would like to thank our speaker for his presentation. Deltas of rivers, of course, contain much biodiversity. The features may be different, and the delta rivers and its climate conditions are very important for the biodiversity of Volga deltas. In the very end, you asked my questions beforehand and in advance, so I had a question, but you have already answered this. Thank you. We have one more presentation today. That is the presentation on the assessment of changes in the Caspian Sea ice cover by the end of the 21st century, according to climate scenarios. Our speaker is Ms. Zhanar Naurozbaeva. You have the floor.
Good afternoon, dear organizers and the participants. So my topic is assessment of changes in the Caspian Sea ice cover by the end of 21st century, according to climate scenarios. Unfortunately, our articles don't have any happy end. The next slide, please. The purpose of this work is assessment of the future characteristics of ice regime of the Caspian Sea based on the climate scenarios and models. we used the data of 29 stations. The blue squares are the stations doing the ice observations. The period is 1888 and 2027. The next slide, please.
Но прежде чем говорить о будущих изменениях, нужно иметь представление, как же изменяется у нас средняя максимальная толщина.
First of all, we should understand how the ice thickness on the Caspian Sea changes nowadays. So there is a picture showing the changes, from 1944 to the nowadays. In the central Caspian, the thickness is about 20 centimeters. Such observations were made when we were talking about very severe winters of the 40s and 50 years of the previous century. If we don't take into account such severe winters, the thickness will be a bit lesser. Of course, I would like to show the differences between thickness in different years. So there is a quite severe and quite warm winter. They both are shown on in the slide. So in the 1953, the eye thickness were about 1 meter. The white line shows the constant ice located on the nose of Kulali Island. Below, we saw another map showing the distribution of temperatures below zero. And we see that the sum of the temperatures is quite big. It means that the winter is very severe. Let's look at quite warm winter. The eye thickness was about 20 centimeters, isn't so big, so the winter was quite warm. The next slide, please. Let's look in the future. As we know, there are a lot of models of climate scenarios. We did our experiments on 10 climate models. In the slide, you can see these models, the models we used. And we've chosen the models the most suitable for our region. We did experiments on the temperatures and the modeled one. The temperatures based on data from different stations and the modeled one. So we're talking about the stations doing ice researchers. The red color shows the most suitable models for our region. They are a British model, French, Russian, and Chinese models were the most suitable. Especially the Chinese model, it was the most suitable for Caspian region. I also would like to draw your attention to the fact that we counted the average temperature for all the stations without Fort Shevchenko and Aktau, because there the ice cover isn't stable. Sometimes there is no ice in the region. The next slide, please. Here you can see the distribution of temperature differences on the whole temperature. We used Russian model, INM, British, model as well. So the changes are about 5 to 7 temperatures. But I would like to draw your attention to the difference between western and eastern part of the Caspian region. Sometimes the model don't take into account these differences. East part of the region is influenced by the high temperatures. The next slide, please.
Можно переключать, пожалуйста, спасибо. И так как мы видим, что у нас была разница, да, между историческими и смоделированными.
Here we can see the difference between the historical data and model data. Of course, there will be some correlations, and we need to correct them. This slide shows these corrections. The blue color shows the historical data.
И, значит, две красненькие точечки внизу. Это
red spots show our data, our current data, and the green color show the modeled information. And the red spots are corrected, show the corrected data. The data were created for all models we used for every station. At the example, we can see January and February models here. The next slide, please.
Соответственно, когда мы уже знаем, как у нас будет распределяться температура воздуха, нам нужно выйти на главный
When we know how the temperature will distribute, we can speak about the temperatures below zero. There we used 3 scenarios. You can see them in the first column. There is a decrease in the sum of temperatures below zero. Let us look at the Hadley model. So it was 682 degrees below zero, and in the last column, the data is 263 degrees. So the changes are very significant. Especially, we can see it in the center of Caspian. The next slide, please. Thank you. Let's look at the average temperature in January using model Hadley. So this picture shows these changes in different periods, and we can see how this temperature changes by the end of the century. The next slide, please. And the summary table showing the scenario sums of the temperatures using the model INM. So there is a special table for Astrakhan. It is located in the right corner. The next slide, please. Here's the sums of the temperatures below zero by model Hadley. We can see the changes. If you see at the first and the third period, we can see that it changed to the nurse. The next slide, please. The next slide, please. So we're interested in the sums of the temperatures below zero in the Caspian region. Here we use the model Hadley. The blue color shows the lowest temperatures. So by the end of the period, we can see that blue color is very small, and the amount of territory with the temperatures from 0 to 300 increases. The next slide, please. This is the data based on the Russian model INM. It's better for describing the sea area, but again we can see that the red zone increases. The temperatures below zero shifts to the north. The next slide, please. So let's talk about the purpose of our work. We need to look how the ice thickness will change. For this we used the French model RCP 4.5. Let us look for the first and fourth period to see the difference. In the first period, the average thickness, eye thickness, is 55 meters, and then 35 meters, then 30 centimeters, 26, and the last period, 18 centimeters. And in some columns we see 0, which means that ice cover does not exist. The next slide, please. Here's the distribution of average ice thickness in different periods. So we can see that the ice thickness is lower and lower. The next slide, please. So there were 5 periods, 2 based on the current data and 3 based on the prognosed scenarios. Here we can see that eye thickness decreases more rapidly. The next slide, please. This slide shows spatial distribution of the average maximum ice thickness. It is based on Russian model. And we show that this line has moved to the north, which will affect not only human activity, but ecology as well, fauna, all the Caspian region. Some animals living in the north of the Caspian area. The next slide, please. Here you can see the results of our research. So we found 3 models, the most suitable for our region: Russian, French, and English one. We can see that eye thickness decreases, and it will increase in 2 by the end of 21st century. There will be more warm winters in the future. The border of ice age will shift to the north as well. So that's all I wanted to say. Thank you. Now I'm end my not so happy research. Thank you. And I would like to answer your questions if you have some. Thank you so much, Janar. Dear listeners, do you have any questions? I would like to mention that Ms. Norazbayeva take into account the average characteristic based on the current climate and the climate in the future. Of course, we see this climate change, and it will exist in the future too. There will be some severe winters, like in Kazakhstan, for example. Such assessments are very important to plan the economic activity in the region of Caspian Sea, including
that also includes oil extraction in the Caspian Sea. So thank you so much, Janar. Dear colleagues, if you have any questions, then you are welcome. Actually, I don't have a question, I have a proposal. I believe this report may be used practically in section number 3. In section number 3, we will carry out it tomorrow. It will be devoted to the effects on climate change on the ecosystem and biodiversity of the Caspian Sea. So I think, what if we formulate some kind of a summary, a short summary, in order to present to the reporters of the third session this very important presentation, this remark on how climate warming may affect the only animal in our sea, on the seal. I know that during the biological sections we will have some reports on seals. That is why I think that your remark will be also important to biologists during the next session. Yes, thank you, Yelena. I think it will be a good idea to present some slides and some sentences tomorrow. We will ask Natalia Ogar to add this presentation into the work of the section tomorrow. But first, I would like Janar to prepare a couple of these important presentations and slides on your report. You carry out an important research, and it was interesting to listen to during the work of our session. Could you please emphasize the possible effect of this climate change on the number of seals in the Caspian Sea region or on other biological diversities of our sea? Yes, of course, I will prepare a couple of slides and then send it to the organizers. It will be good if more people could take a look at this presentation, because I know there are a lot of projects to protect the Caspian seal. Recently, a new Russian project was launched. It is called the Caspian Soul. And I hope our colleagues will share the results tomorrow. Thank you so much. If you have questions, you are welcome. Dear listeners, do you have any questions? Janar, your son wants to take a look at the presentation, I see. Yes, we take part in 2 conferences from the early morning, so that is why he's eager to know. Thank you, Janar, once again for your presentation. It was of great interest and use. Your presentation concluded our session today. Of course, all presentations were of great interest, but some of the reports are of applied nature and may be used widely. And now I would like to ask the organizers if there are no other questions, of course. First of all, let's think, do you have any questions about all of the reports mentioned today? I mean, the sessions that we had before lunch and after lunch. Of course, I know that for some of you, it is already evening time. Unfortunately, I had not enough time to ask my question due to the timeline. In my work, I took a look at CMIP5 model, and as far as I know, some of the reporters already use the CMIP6 models, and they use quite great results according to the Max Planck model, for example. I mean, Kim Stadelmeier and her report, and the next reporter, as far as I remember, it was Azar. I would like to ask a question. Compared to the previous models, the network there is much smaller, just not 0.5 degrees. And for the comparative analysis, I guess these models are much more suitable. If we take a look at the Caspian region, I had such problem. It was a problem to cover some of the steppe territories. The model doesn't work well with them. And about this MP6 problem, does it pay an special attention to this issue? Are there any smaller deviations for the temperature values? Did you carry out any comparisons?
Госпожа Ким Штайдельмейер.
Ms. Stadelmeier, could you please answer the question?
Yes, sorry, but could you recap the issue you had with the MPA or with the temperature then?
Так, еще раз вопрос. Модели, которые
So the question about the models. Those models that are on the SMP5 assembles and that are also part of the SMP6 models and the Max Planck model have a net of 0.5 degrees. Do they have a better projection of the air temperature for the future as compared to the models that were used in the SMP5 program? What is the deviation? Does it pay attention to some orographic peculiarities, the presence of water bodies, for example? Because I know we had a huge problem when we worked with previous models.
Yes, okay. So I can tell I didn't look into the future, so I only looked at the historical, so present day simulations and then the past. And they're also only in the lower resolution models. And there we do have the issue with orography and that Elbrus Mountains are not represented so well that we can't see the features. But for the future simulations, there are also simulations available with higher resolutions. And as Matthias Prange pointed out, that there with the 1 degree resolution, it is much better. So I guess it will also be valid for the future simulations, but I didn't look at this, I'm sorry.
Спасибо большое. Ну, я так
Thank
поняла,
you.
что даже по тем историческим данным у вас ошибка
As
была.
far as I understood, the deviation was not that big for the historical data that you received, right?
Yes, for the temperatures, it was quite well, but also the plots I showed was in a range of 5 degrees. So this 2.5 degree differences we wouldn't have seen in the figure, but still it was for the temperature in where I looked, yeah, it was reasonable.
Спасибо большое.
Thank you so much. I see that Said Afarov has a question. Said, you're welcome.
У меня вопрос нашему товарищу из Ирана, который...
I have a question for our Iranian colleague who was speaking about the 4.2 event. Unfortunately, I cannot remember his name. According to the diagrams, I saw that the air temperature change was not that big, probably 5 or not more. But in your presentation, you said that they were drastic changes. How can you describe it? The temperature has increased by 1.1 degrees, and we didn't see a great change in our civilization. But why 4,200 years ago we had such an emergency event, I would say? Mr. Hadi Girivani, could you answer this question, please?
Unfortunately, I'm afraid he's not here with us right now.
Ничего, потом я свяжусь с ним и поговорим.
Okay, that's no problem. I will contact him a little bit later. Thank you. Maybe we have better technology, so that is why we can adapt to climate change as compared to people who lived 4,200 years ago who cannot survive long drought periods. Well, that might be true, but I took a look at their diagram. So the change was step by step, and we have more leaping changes. We cannot see some emergency events. So maybe the change was not about 5 degrees, but 1.5 or maybe 2. But as far as I remember, the scheme shows 5 degrees. In any case, thank you. Do we have any other questions? Dear listeners? So I can't see any hands. We have half an hour left. And we have some recommendations prepared by the organizing committee. They have done this based on the abstracts that you presented to the organizing committee. These are the recommendations made in accordance with the state of science and with the work of various organizations. The text will be presented and displayed in English. We have already sent this text to you, so if you cannot see it on your screen, you are more than welcome to open it on your devices. We have already provided you with a copy. First, we will read this one in English, and then we will display this document in Russian. So I suggest reading these recommendations. And if you have any amendments, then you can tell us. But if you have any further amendments after the conference within a week, then we are waiting for your proposals. And now let's read them.
Покажите, пожалуйста, нижнюю часть текста.
Could you please show the lower part of the document?
И мы видим, что рекомендации разделены на две части.
We can see that recommendations are divided into two parts. The first part of recommendations is related to decision makers and international organizations. And the second part is related to the scientific and academic community.
И теперь, пожалуйста, на русскую часть
And now,
текста.
could you please open the Russian version?
А можно еще небольшое вот дополнение, где вот идет верхняя
I
часть?
also have a small remark. In the upper part of the document, there is a list, such as increase in air temperature, decrease in river flow, etc. Can we also put in the following information? The ice regime change of the Caspian Sea. Because we do not only speak about the decreasing of the ice cover, but we also have a timely shift. The ice period is decreasing, and the sea tends to lose ice 10 days earlier as compared to the previous history. So I think we can also put ice regime also on the list. Well, yes, I think we can do so, because in this case we will have a wider representations of the problems. Thank you.
Есть еще дополнения?
Do you have any other additions?
Да, конечно.
Сейчас я открою с телефона, мне так проще
Dear
видно.
colleagues, I will open the document on my mobile phone right now. I have a proposal. Madam Moderator, for a couple of times you have stated the importance of the deltas for the preservation and development of biological diversity of the Caspian Sea region. I believe that in the first section, where we have recommendations for the Caspian states, it would be also important to add the promotion of regular research projects on the current state of the pollution of the marine area and the river deltas of the Caspian Sea region, because we have some transporter water bodies, such as the delta of the Volga River, and we also have other deltas that play an important role in shaping the ecosystem and biodiversity of the Caspian Sea region. We do not carry any mutual projects, research projects, I mean, and I think that is a huge gap as compared to the previous years, where we monitored the situation constantly. So let us also put this on the list. Of course, if you don't have any objections. I think that is a good proposal, and we will have no objections. Of course, deltas play an important role for such a huge lake as Caspian Sea. We have a huge delta of the Ili River that flows into the Balkhash Lake. The level of biodiversity is also high there. There are many projects that lead to the preservation of the delta of the Ili River and the preservation of biodiversity. On my side, I can only support your proposal, and I think there are no objections. Modern states of the pollution is my solution. Thank you so much, dear colleagues.
Excuse me, this is Daniel speaking here. Can you please repeat the recommendation that was agreed and where it should be included into this recommendation page? That would be better for us to take note of every change that has been made. Thank you.
Let's in English. What is better for you?
Maybe in English, what is better for you, Daniel?
For me personally, it is of course better in English originally, but we have translators, so they make sure that I also understand the Russian. So it's up to you. But it's just, I wanted to make sure that I understood you correctly.
Хорошо. Хорошо. Первый пункт. The Caspian States 2.
The first one, the Caspian States 2. Second part. Here with mutual research
моря. Хорошо. После слов marine environment and
after
state.
the words marine environment and state of biological communities, could you please add Caspian Sea and river deltas of the Caspian Sea?
Okay.
Можно вмешаться?
Да, конечно.
Can I just intervene? Well, I have a different proposal. We speak about the pollution of the marine environment.
Отлично, да. Верно.
Daniel, after marine environment, please add and river deltas, and that's all. Yes. Thank you.
Следующее убрать. Да, окей, окей. Fine. Ольга, спасибо большое. Есть еще комментарии?
Thank you very much, Olga. Any other comments? Yes, I also have a comment.
Это можно у меня там одно предложение?
I also have a proposal.
Внизу там есть поручать, значит, ученым, вот так обменяться, значит, результатами исследований, вот так.
In the bottom, there is some statement on the exchange of information and data.
Мне кажется, что надо добавить, чтобы, может быть, не ученым.
I think we should only add not to exchange between scientists. That covers not only scientists, I guess, but the states themselves. I think not.
Но у нас этот раздел посвящен именно рекомендациям к научному сообществу.
I think that is a recommendation not only for the academic and scientific community, but for the states.
Но в первой части, когда мы говорим о на основе глобальной системы наблюдения,
The first part, when we speak about the global observation system, then in this part we of course mean the exchange of information among countries, because we speak about the global framework basis, and that means that the states have to act and exchange information in order to disseminate all data we have.
Допустим, есть Институт географии Азербайджана, и ему нужны данные по Казахстану, допустим, по температуре, по осадкам и так далее.
And what is the mechanism that we can use to share this information? How do we do this? Shall I contact my state authorities, and then state authorities of my country will contact the state authorities of your country? What is the procedure?
Да, Лена.
Svetlana, may I answer this question? Yeah, Yelena, you're welcome. The Institute of Geography of Azerbaijan may contact its weather service. Within the Caspian committee, we are providing the data to each other. Our weather services are constantly sharing the information on the state of the marine environment of the Caspian Sea. First of all, of course, we share hydrometeorological data and information, but also we disseminate data on air temperature, salinity, river inflow, river runoff volumes. You can also find information that you want on caspcom.com. There you can find average data. And we have information on all states, and the access is free, of course. There you can find only information on months, right? Yes. Information that we have agreed among our states within our agreements. Thank you for the information.
Я не услышала. Кто? Я больше не вижу поднятых рук.
I can see any other hands. I have a small remark too. Don't know whether it is a good idea or not, so you are to decide. Let's take a look at the second section. I mean the recommendations for the scientific community. Can you please also end hydrogeology on the list, because we have many researchers that deal with these research projects. They examine the bed of the sea itself. We have many interesting tectonic projects, wave projects. So could you please also add hydrogeology there? That is just what I suppose.
Это вот второй вот подраздел.
That is the second sentence of the second part, where the scientific community do, and then we have hydrophysics, hydrochemistry, and ecology, etc. Жанар, so we speak about the influence of hydrometeorological changes on climate change. So you say there are research projects.
Нет, это будет в обратном тогда идти. Гидрогеология и уже будет влиять на метеорологические какие-то
Of course, we speak about hydrogeology that affects some weather parameters.
Хорошо, тогда мы, наверное, не будем включать гидрогеологию.
Okay, let us not put hydrogeology on the list. Let's exclude it.
На ваше усмотрение. Я просто предлагаю.
Okay, as you see, that was only my suggestion to add it on the list, but Daniel, let's exclude hydrogeology.
Или сформулируем отдельное предложение.
We can also formulate an additional sentence. That is also an option.
Но в те пункты, которые сейчас записаны, гидрогеология пока не вписывается. А если вписывать, то надо отдельным пунктом.
I think if we are to put hydrogeology, then it needs to be done in a separate paragraph because it doesn't seem to suit all the mentioned sentences.
Давайте мы дадим время подумать над этим пунктом. Спасибо.
Well, let's take some time and let's think about it. Thank you, Janar, for your amendment and for your proposal. We have written it down and we will consider this sentence. At least we have time till the plenary session tomorrow.
Ну вот уже
Даниил
появился.
уже записывает.
Да.
So Daniel decided to write it down. It's good.
Жанара, спасибо большое.
Janara, thank you.
Есть еще рекомендации?
Any other recommendations?
Рекомендации. Комментарии.
Do you have any comments? Probably.
Ну, если нет, то, возможно, мы будем закрывать.
If you have no more comments or no more recommendations, I think we will come to the end. Yelena, do you have any questions or any remarks? First of all, I would like to thank you, Svetlana, for moderating this session. Your moderation was effective. I would like to thank all of the speakers for their presentations. And I would also like to express my gratitude for your participation in the work of our session. Thank you. I would also like to thank all of the listeners, all of the speakers who spent so much time today for the work of our session. I hope it was interesting because we have different and various topics, different presentations on the future, on the past, and on the present state. Thank you so much. Matthew wants to say something.
from the room number 2 that we have finished our session, and using this opportunity, just a small request to all of you to switch on the camera so I can take a digital group picture of the session today. So if you don't mind, switch on the camera, and then Daniel, can I ask you to stop sharing the screen? So we will have maybe a small digital, nevertheless, but a souvenir from today's session. So I will give you a few more seconds, and I think that's the best role that I have, because I didn't have to be in the deliberation, but I can take just a picture, which is quite easy task. So a few more minutes, and then I can see people are indeed switching on the camera. I can see some smiles. I believe then that you had an excellent session. Yes, all right. Just a second. Lovely. And 1, 2, 3. And I will take one more, so we can choose later on which one is better. 1, 2, 3. All right, thank you very much. And I'm sorry for this short disruption from my side. And I want to give the floor back to Svetlana.
Ну, у меня единственное слово — это закрыть нашу секцию, поблагодарить.
So my only task is to finish the session today. I would like to thank all of the participants once again. I guess tomorrow we will have another session of great reports and presentations, not only on the climate change, but on the effects of climate change. That also includes adaptation to climate change, and I hope we do have opportunities to adapt to climate change. You are welcome to join our scientific conference tomorrow. Thank you very much, and have a lovely evening.
Светлана Анатольевна.
Да, я хотела еще сказать большое спасибо.
Я как рапортер вам отправлю сегодня.
Svetlana, I will send you all of the documents for you, so that it is easier for you to make a presentation during the plenary session. Yes, thank you, Yelena, so much. I would also like to express my gratitude to the organizers. You have supported us so much. And of course, I would like to thank all of you once again. Thank you for this beautiful organization. Thank you all once again. See you tomorrow.